literally match that symbol. So in a file, if you want to actually find if there is a plus symbol there or not, then if you're using BRE, you simply put that plus in your pattern and it will match that. And if you're using ERE, you have to escape that plus. So you have to use \+ if you want to actually find the symbol plus in your file. Whereas if you want to use the special meaning of these symbols, so question mark means 0 or 1, so present or absent, plus means 1 or more than 1 times present, etc. So if you want to use these special meanings, then in ERE you can simply put that. So A plus B here means multiple occurrences of A followed by a B. So one or more A followed by a B. So that you can directly use plus in ERE, whereas if you want to have that special meaning in BRE, you have to escape that. So two use cases, literal and syntactical meaning, and two languages, BRE and ERE. So for these 5 symbols, you need to, so if you want literal, you use BRE with unescaped or ERE with escaped. And if you want syntactical meaning, you use ERE unescaped or BRE escaped. So in grep, you can use ERE by using -E. So this will give you.
What do you mean by syntactic meaning? Just if you can go back. So in the second one, A plus B, if you want to, in the right one, in ERE, A plus B will be a
this thing. One or more A followed by a B.
So here A plus B will be special characters, right? Yeah.
Yes, this plus is has a special meaning, which means
Correct.
1 or more. Yes, and because it's after A, so it quantifies this A. So A can be present 1 or more than 1 times, and B has to be only present once.
So dot, which is basically for any character,
yes,
that has to be escaped. If we want literal, it has to be escaped in both ERE and BRE.
Yes, so there is no difference in BRE and ERE with the dot. So in both of them, it has to be escaped.
Are there any other characters like that which have special meaning in both and have to be escaped if we want literal? I could only think of dot.
Yeah, we have the caret for the start of line and dollar for the end of line.
But those have special meaning in both.
Yes, so you have
to, literal. Okay. Got it.
If you want literal, you have to escape in both. So the symbols that have different meanings in different languages, they are only these 1, 2, 3, 4, 5, 6, 7. These.
Got it.
Yeah. So others you can see in the BRE syntax. So there are symbols which has meaning. So for example, star. If you want a literal star, you have to escape the star. If you want a literal dot, you have to escape the dot. If you want a literal hat, so like this, you have to escape these.
Does hash have any meaning in any of them?
Not that I'm aware of. No, hash itself matches a symbol. So we can also test it. So if I do echo hash, and I can do grep hash. So yeah, hash does not have any special meaning. It matches the literal symbol hash.
Okay.
So this way also we can verify quickly whether this is matching the symbol literally or it has some special meaning. Right, so we can see for plus it will match literally in BRE, but for star it will not match literally. So here star, okay, so here star is matching literally because star is a quantifier and I don't have anything before it. So for example, if I have A star B in the line and I search for A star B, so then it will not work because here then star is acting as a quantifier of this A. So if I want to match it literally, then we have to escape it. So I have to make A \star B. So then it will match this thing which we are searching for. So similarly, if we have plus here, so plus by default is matched literally in BRE, but if we are in ERE, so using -E, then this will not match. We have to do a \+ to match it literally.
The first one, A star B, why did it match A? Because A star means A
0 or more times.
0 or more times, but A is there, right? So
yes, A is there, but after A, B is not there. After A, we have a symbol, star symbol. So it is trying to match as many A's as possible followed by a B. So here there are no A's followed by a B. There is only a B. So it matches 0 matches of A and 1 match of B. Okay, so that is how BRE and ERE works, there's also another thing called fixed strings. So if I don't want to use regex at all, if I just want to match something like, so for example, as we saw the star example, if I want to just match A star B, and I don't want to have, like, I don't want that I have to escape it. So I just want to give a string and I want it to match exactly. So like if we are giving the string manually, it is possible for us to escape it. But sometimes when we are taking the string from some other place, maybe some file or something, then it is not possible for us to escape it. So in that case, we can simply use the -f flag to interpret all strings as simple strings and not regex. So this will also directly match whatever we are searching for. And G is the default, which is BRE. So even if you don't mention this, this is the default. So there is also another syntax of regex, which is Perl regex. So this is not there in the system commands syllabus, so we will not delve deeper into it. However, if someone is familiar already with ERE and BRE and wants to explore something, please go through what PCRE is. So PCRE is basically like a superset of ERE, so it can do everything ERE can do, but it can also do some extra stuff. So things like look around, positive look around, negative look around, etc. So we'll not discuss those, but you can go through it. So it is even more powerful. If you want to do some complex search, you can use PCRE in that case.
But in the NPP, that color, that BGB, that can be done using this PCRE easily, right?
Yes, yes, it will be easier with PCRE, but it can also be done without that. Yeah. So we can then match multiple patterns with grep-e. So for example, if I want to match the word pineapple in the word list, so I can do grep pineapple and it will match this. But if I also want to match some other words, so for example, just give me some word in English.
English.
Okay, yeah, we can match English also. So if I give -e, what this will mean is if this pattern is matched or this pattern is matched, then print the line. So both the lines that have English and the lines that have pineapple are matched. Obviously, if a line has both the words, that also will be matched and printed. But it does not ask that the line has both. It can have either of them. So this -e, we don't need to give if we are just giving one pattern, so that is default. But as soon as we are giving multiple patterns, we have to give -e for the others and also for the first one. So -e basically means we are giving multiple patterns. So here we can give as many patterns as we want. I have simply shown with 2 patterns. So if we have, let's say, 500, 600 patterns I want to search against, so in that case, we cannot usually do it in the command line because it will become very hectic to put all the -e and the patterns side by side. So then we use the grep -f. So we put all the patterns in a file and we search over that file. So for example, here I have, let's say, uh, a file which has the patterns. So here I will add the word apple or pineapple and the word English. So if I now do grep -f patterns, so it will go through this file to look for patterns, and each line it will read as one pattern. So this is same as putting that many -e, as many lines there are. And then we will search on the words.txt file. So this is giving us the same output. So this is the default way of using this. But obviously, when we have a flag like this, we can also use this to do some other things. So for example, I have here, I have taken the top 50 words from this dictionary. So like the first 50 words, and I have shuffled them. So SFUF simply shuffles them. So in any random order. And then I've taken the top 30 of them and stored them in a file called words1. And I'm doing the same thing and storing them in words2. So because we are shuffling, so so the order is different in both of them. So some lines might match in words1 and word2. Some lines might not match in words1 and words2. So we can actually do it for all the lines also. So for example, if I do it simply for all the lines, so this will have any random words, but then the probability of matching diminishes a lot. So I'm only taking the first 50 and shuffling and taking the first 30. So you can see the files also. So if I do words1, You can see it has all these words in it, and words 2 has all these words in it. So some of them are common between them, some of them are different. So for example, it has 9 point, so that is there here also, but it has 7 point, which is not there in that file. So how can we match lines which are there in both the files? So we can make use of this -f flag, which we saw earlier. So we can ask grep to treat one file as a pattern file, let's say word 1, and the other file as the file that we are searching over, words 2. So what this will do is it will read each line of words 1 and treat it as a pattern and search for that pattern in words 2. So it will print all those lines in words 2 that match any of the patterns given in words 1. So this works for some files, but in this case, it might not work for some other files. So you can see, for example, it is matching for 2. So the line 2 is present in words 1 and it is present in words 2. But the line 2 comma 4 minus b is not present in words 1. But because the line 2 is present in words 1, it is searching for the pattern 2, and the pattern 2 is matching in this line also. So it is printing also that line. So that is not exactly what we want. Another example is this 8 point. So 8 point is there in both the files, so it's printing 8 point. But 8 point is not there. So 18 point is not there in words 1, but it is there in words 2. But because 18 points contains the text 8 points, that is also being printed. So that is not what we want. We want the pattern we are searching for to be the only thing in that line. So usually if we are doing that in regex, we use the start of the line and then whatever pattern we are searching for and then the end of the line. So if we want to do it like around the entire pattern, this is one way. Another way is to use the X flag. So the -X does the exact same thing. So it will only print those lines that match the pattern entirely. So there is nothing to the left of it or nothing to the right of it in that line. So instead of doing this, I can do.
Words 1 has some words. Words 2 has the shuffled words, right?
No, both of them are shuffled. So they have 30 words each taken from the word list. So some of them are common between them. Some of them are not
Okay.
same.
And we are trying to find the common ones. Is it? Sorry, I lost track.
Yes, yes, yes.
Okay, I was just reading on the right. Sorry. Yeah, I could.
Yeah.
Can we consider here as word 1 as a patterns and word 2 as the input files, and word 1 the patterns which are matching the patterns which are in word 1 which are matching the word 2 are
Yes,
printing.
that is
Can we
that
consider
is yes, that is what is happening. But
Okay.
if we want to, let's say, treat both of them as normal files, and we want to only print file lines that are common to both, so we will see how we can do that. So this was our first attempt, so we can see it's working somewhat, but some issues are there, right? So even things that are matching partially are being printed. So that we can tackle by using the X. So X means only print lines where the pattern matches completely. So let us see one example of this first. So if I do grep pineapple in the like words.txt, which has all words of English, you can see it prints pineapple, pineapples, and pineapples. Here, if I now do grep -X, this will only print that line which matches exactly with this pattern. So the pattern can be anything. So instead of it might not be a fixed string. So for example, instead of I can put a dot here, and still it is matching because there is only one line that matches this. So it will still treat this as regex, but it will only print those lines that matches this exactly. So there is nothing more to the left of it or nothing more to the right of it. As you can see, it is still regex. So things like bake apple, crab apple, all these are matched along with pineapple if we are doing dot 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 apple. But it is not matching anything that has anything after it or anything to the left of it. So this has to be the entire line. So if we try this with this now, so here you can see now that is an improvement. So it is only printing those lines that match completely. So lines in A that like lines in word 1 that match lines in word 2. But there is still some issue that might occur. So can anyone point out what that issue might be?
We want the exact match of the word.
Yeah,
Like
so we are
we,
getting the exact match, But as you said, so internally what is happening is this is treated as a patterns file and this is treated as a text file. So what issue might occur if like the lines of words one have some special meaning?
Like the carriage return, LF, all those things.
No, those will work, but see, the issue is this is treated as a pattern file. So each line of words one will be treated as a pattern file. So pattern. So for example, this line A dot A dot A dot in words one, this will search for actually in words two any line that matches A, then any character, then A, then any character, then A, then any character. Whereas we want lines that match exactly, right? So that match exactly A dot A dot A dot. So how can we ask grep to not use regular expressions?
The W, I think W will solve that. That option we mentioned minus W.
No, W will
Minus
match for
F.
Exact
yes,
word.
minus F, right? So minus W will match exact word. We don't want that. We want to match entire line, so that X is fine.
So
But
you
we need
put
to use
minus E.
no, minus E will do extended regex. We need to use minus F, minus capital F. So we want to treat all these patterns as fixed strings and not regex. So now this is the correct way of finding lines common between two files. So we'll see what is the issue with the first one. So if I do this, right now it might not seem like an issue, but let me change words one. And let's say one of the line in itself is dot star. So I think now it might be more clear what is the issue. So if we search for the pattern dot star, then what will be the output?
It will match everything.
Everything, right? So all the lines of words two are printed. So you can see everything that is not there in words one also is printed because it is taking that dot star as a regex itself. So we are not getting what we tried to do, which is matching the line as it is as a string. So that's why if we use F here, only then it will give you the lines common to both of them. So now you can see it is only printing lines that are common. So if we add dot star in the words two also now, then it will print that here as well. So if I do dot star here also, and if I run this, so you can see now dot star is also printed because this is only treated as a string. So it only matches if that same thing is there and the regular expression meaning is not taken. So yeah.
So, no, go ahead. Sorry, finish.
Yeah, so this is how you match, like how you print lines that are common in two files. So X is for matching entire line, so we don't take substrings. F so that we actually match like the string. We don't take any special meaning of any character. And F to use this way of using one pattern file and one file to search in.
Shane, you had done that minus X initially when you were showing P dot apple. Can you just reprint that command from history?
Yeah, this one, right?
So there P dot, okay, pineapple. Okay, got it.
Yeah.
And it will only match pineapple dot dot dot. That's any 4 characters. Correct.
Yeah.
So just one second. So this. Good, Shane.
Okay, yeah. So this is how we match anything that is present in both the lines, both the files. So now if I want to print lines present in one file but not in other. So for example, lines present in words two but not in words one. So let me create another file so that it's easier to see. So for example, let me have a file called colors where I add a few colors. Okay, I think that's enough. And let me add another file called fruits that has a name of some fruits. Okay. So if I run that same command again, grep xff on colors and fruits. So you can see the only thing common between colors and fruits is the color or fruit orange. But if I want to print all the fruits that don't share a name with colors, so how can I do that?
Minus B.
Yes, I can add simply a V here. Right? The V means inverse matching. So now I will print only those lines of fruits that don't match any of the patterns given in colors. So then we will see only apple, banana, cherry, and mango. Right? And if we want to print lines of colors that don't share with fruits, we can simply reverse the order. So here I can put it as fruits and colors, and then I'll get all the colors that are not name of a fruit. So orange is again not there. So when I'm using V, then this is not commutative basically. So this means fruits minus colors, and this means colors minus fruits. When I don't use the V, then it means a line common in both. So the order actually does not matter.
That either or question that we had in the OPP, that I don't think we can answer in this. Right? We are doing common intersection.
Yeah.
Basically, A not B, B not A, and A and B we are doing here. So the question in the OPP was A and B. Sorry, A or B, which I think.
So
Yeah, A or
Shan,
B. You
that
can do this. Yeah.
Shan, if you almost finished the entire set theory, so
Yeah.
A union B, can you do with this? Unless you can pipe multiple times without.
Not with grep, yeah, but A union B you can do by doing something like cat fruits and then colors. So this will print both of them, and but then there will be duplicates, right? So if I do cat fruit colors, yeah. I think someone is asking something.
No, sir, we can pipe it to short minus C too.
Yes, yes, exactly. So if you do simply cat, it will print both of them one after other. So then if you do sort and then dash u or sort unique, both are same. So then you will get, so it will not preserve the order, it will be in sorted order. But now you will get basically the union because you are removing the duplicates. Which I can also use sort minus u. So this way you can get union.
Sorry, Shan, I'm a little confused now. See, the earlier one which we did, X, F, F, right?
Yeah.
That was A union B.
No, that is A intersection B.
Sorry, A intersection B.
Yeah.
Then X, F, F, V would be the things which are not, which are basically B minus A.
Yes. So the V has to be before the F, because this F is a flag that takes a value which is the fruits. So V can be anywhere here, but not after the F. So just one small correction to that. So like that confusion should not be there. So if I do this, this is common. If I put V here, it is fine. If I put V here, it is fine. If I put V here, it is fine. But if I put the V here, then it will give you an error because the F is looking for a file and the next thing is V. So it is thinking V is the name of the pattern file. So the V can be anywhere else, not after at the end. Yeah, go ahead.
Sir, can you
was finally showing the union one, if you had.
Yeah, so for doing union, we don't use grep. So for union, we can simply print out both of them and then we can remove the duplicates. So sort minus u, it will remove the duplicates.
This was there for one of the questions was there.
Yeah, yeah.
I think it was question 2 or 3 in the first batch.
Yeah. We can also do it without changing the order of the files by using awk. So basically we create a dictionary and store all the things of file 1 and then we basically go over file 2, and if it's already present in file 1 we don't print it, and if it's not present in file 1 then we print it. So that way we can do it without changing the order of the file. But if you don't care about the order, then we can do it directly.
No, session 2 also had that A minus B, which is it's
Yes.
present in A, not B, or one version of that.
Yes, yes.
So what does hyphen U do? It's unique.
Hyphen? Yeah, it is for unique. So this is same as piping it to unique. Because because unique needs the input to be sorted. So that is one of the major use cases of using the unique command itself. So because sorting and uniquing is very frequently done, so it is even a feature of sort itself. So it can directly do it with a flag. Okay, so that is taking commons. So we can take the intersection and we can take lines in, so this should be B, not A. Lines in B, but not in A. So we can also ignore the case using I. So for example, if I grep for apple in the words.txt, so it does not return anything because all the words there in lowercase. But if I don't want to care about the case, I just want to care if the match is there or not, then I can use it -I to match case insensitively. So this again will match even the sub words. So I can use W to match only whole words. So now you can see only whole words of apple are matched. So apple, and then things that have apple as a whole word. So here this dash is considered as a delimiter of words. So apple and cheek is not considered one word, it is two words separated by a hyphen. So you can see we only get things that have apple as a word, whereas earlier we also got things that was apple as substring. And instead, if I just want the entire line to just be apple, so I just want out the first line as output, then instead of W, I can use X, which means match the entire line. So then I get only apple. So these are like one of the most frequently used and most important things for grep. So matching patterns in file, ignoring the case, and inverting the match. And we can match whole words with W and whole lines with X.
So it's equivalent of using regular expression word boundary
Yes.
like \b in front of the
Yes.
pattern and after the pattern, right?
Yes, yes, exactly. So these are just shortcuts. So word boundary we can use with \b. So this, as you can see, will give you the same output as the W. And X is just a shortcut for the start of line and end of line. So this will give you this. So if we are doing it, like if you're using, let's say, word boundary somewhere inside, so I'm telling it has to be apple and then there should be something, let's say, that starts with F. So apple faced and apple fellow, something like that. Okay, and then there is one delimiter. So we can use like the word boundary inside the regex also. So if we are not surrounding the entire regex by word boundary, then we have to obviously use it inside the regex explicitly. But if it is simply we are checking this way, so we are just doing something and then around the entire search, we are putting line boundary or word boundary, then we have a shortcut for that using the W or X symbol.
It's interesting. So it is you're basically searching for apple followed by any character and F, right?
Yes.
But there is no gap or any other character between apple and that. So it is still considered as a word boundary.
Yes, so this hyphen is there, right? So hyphen is considered as a delimiter for words. So anything that is not alphanumeric is a word boundary.
Oh, okay. So got it. So this is a trick question, MSQ.
Yeah, so here if I don't give this word boundary, okay, so in this case it is like there is nothing else that matches. But basically, so it might be that this dot can also match a alphanumeric. But if I give this word boundary, then this will only match non-alphanumeric, because the word boundary will only match if this dot here is a non-alphanumeric. So let us see if there is some things that we can test this on. So let me search for hash. Okay, so maybe quoted, there might be many. What happened? Invalid option P. Okay, so this is being taken as an option. Yeah. So you can see there are a lot of things that have quoted with hash, and if I remove this, so some of them are also without hash. So this under quoted is without hash. So if I say simply any symbol and then quoted, so this will match all the hash quoted also, and it will match all the like some letter quoted also. But if I don't want to match basically things that are part of a bigger word, so I basically what I want is quoted should be a word of itself, and before that there should be some letter that I want to match. So some non-alphanumeric. So this one will only match the ones that has hyphen in it, and the hyphens will also be matched.
Can you just show that syntax again?
Yeah. So the \b does not match any character itself. So when I do \b quoted \, it is only matching the quoted part. The delimiter of that word is also not being matched. So here hyphen is the delimiter, but that is not matched. So \, just means that there should be a word boundary, but it is not matched. If I want to match that, then I have to put something that will match it. So I'm just using dot because dot matches everything. So here in this case, it will match the hyphen. So if I
Basically,
just
hyphen and all also will be treated as word bound. That's the.
yeah. So anything that is not alphanumeric is a word boundary.
Oh.
So here, if I don't give this \b, then dot quoted will also match things like this r quoted, n quoted, etc. But if I give this word boundary, then that means that whatever this dot is, so logically this obviously cannot be a letter or a number, because if it was a letter or a number, then it would not have a word boundary after that letter or number. So the presence of this \b means this dot will only be a non-alphanumeric. So only things like hyphen are matched. So the next important thing is the -c. So for this one, for example, how many matches are there? So I cannot, so I can maybe count one by one, or I can pipe it to wc-l. So wc-l is a command that simply prints how many lines of input are given to it. So it tells that there are 58 lines of input. And we know that because grep prints each line of match on a separate line, so we know by that logic, there are 58 lines of matches. But we can also directly get that count in grep using the -c flag. So this will also print the exactly the same thing as piping it to wc-l. So this prints how many matches, how many lines of matches there are. So if let's say we have some line which has multiple matches, so then this will not print the count of matches, but only the count of lines. So for example, if I have, let's say, a file called hello, and here I have one line which has hello, and then it has hello somewhere else. Uh,
Hello world.
yeah, hello world maybe. And it has also a line called hello, hello. So the total number of occurrences of hello here is 1, 2, 3, 4, 5. So if I do grep hello in hello, so this is the pattern and this is the file. So then it matches all the matches. So obviously there are only 4 lines. So wc-l will obviously print 4, but grep -c will also print 4. So grep -c and the output of wc-l will always be the same. If I want the count of how many matches there are, then how can we do that?
-w.
Minus
The-
W
In the
will
WC, if
not
we
work.
pipe it to WC -w,
Okay, okay. If we no, so see, if we pipe it to WC-W, it is giving us 9 because there is a total of 9 words here. 1, 2, 3, 4, 5,
oh,
6,
sorry,
7,
sorry.
8, 9. So it's counting.
No, grep
Yes.
grep minus C
Minus-
won't do that.
Yes,
Grep
minus
Minus
C. No, -C prints the number of lines that match, not the number of matches.
So can I
Number
do
of-
grape in the grape? I can do -o, then pipe it
Yes,
and then
yes.
do WC-w.
Yes, this is the way to do it. So if you do grep -o, this will print only the matches. So like that is what we know, that if there is a line and the match is there, it will print only the matches. But it also does another thing. If there is a line which has multiple matches, it will print each of the match in a separate line. So the first 4 matches are like the first 3 are from that line, and the 4th and 5th it will print in separate lines. So then we can simply count the number of lines using WC-L. So this way we can get the number of matches by using -o and WC-L.
Shayan, the first one,
Yeah.
grep hello hello, that will anyway give.
Yeah.
No, that will only give the lines.
Yes.
Number of words. What was the problem with number of words?
No, if we print the number of words in the output, it will also count how many, like it will count how many words are there in the output total. So
All
it
the
will
lines.
also count non-matches. Yes.
Okay. Here,
So yeah.
W grep hello hello O WC W minus W
Yes.
also will work, not just
Yes, that will also work. So this will only work if the what you're searching for is one word. So let's say I am searching for something else. So let me demonstrate that also. Let's say in the let me create another file. So counts. So here, let's say what I'm searching for is A space B. So I have A space B space like this, and then So I have multiple occurrences of that. So what I'm searching for is A space B. Okay, so number of lines that match is 3, and number of occurrences is obviously 4. So this is the first one, this is the second one, and this is the third, and this is fourth.
1 second, CD.
Yeah.
Okay, go ahead.
Yeah. So sorry. So if I do grep A space B in the file counts, it will show me the matches. So it will print the entire line. And if I then do minus O, then it will print all the matches in a separate line. So here, if I do WC minus W, the answer is 8. It is number of words in the output. But I don't want the number of words, I want the number of matches. So match is A space B entire thing. So the minus W might work in some cases if what you're searching for is one word, but minus L will always work. So it will give you how many matches there are.
Particularly when you have multiple matches in a line, then it is troublesome. If you have got
Yes.
one, then if you have got a word separated in a new line character, then it's not a problem. But if you
Yeah,
have-
then anyway, like without O also, it will give you the correct count. Yeah. So that is how like the minus C and WC are useful. So if we are searching, counting only the lines, then we can directly use minus C instead of using WC minus L. But if you are counting occurrences, we use minus O and WC minus L.
Would minus X also work here?
Minus X means that what I'm searching for should be the only thing present in that line. So here, if we do minus X, then output will be empty. There will be no lines.
Oh, okay.
Because there is no line that is only A space B.
So one minus O minus C what?
Minus O?
And minus C.
No, so that will still print number of lines that match, not the not the number of counts. So you have to use WC minus L. Or what you can do, if you want to use grep only, you can do this to get this. Then you can do grep dot minus C. So that can work. So you can use multiple greps in that case. So dot means any character. So this will basically match all lines. And if you are like if you want to match, let's say, empty lines, you can do dot star also. So in normally dot should work. So then you use minus C to print the count. So this is basically same as WC minus L, this thing. So instead of using WC minus L, you can also do this roundabout way. But at this point, then WC minus L becomes easier to type than this. Okay, so let's move on. So we have been doing only grep, so we should also move on to sed and awk. So I'll just show you a few other examples which might be useful, and then we will move on to the next ones. So for example, if I do grep apple in the words.txt, then there are a lot of outputs, but maybe I don't want all of them. Maybe I want only the first 10. So one way is to use the head command. So head and 10, it will give you only the first 10 matches of that. But we can also do it directly in grep without using any other command, using the M flag. So if I do M and then give a number, so M stands for max counts, how many maximum counts we should have. So this will give you only the first 10 matches. Right, so let us see one thing now. If I have in this hello file, so if this hello is, let's say, at the top. So if I do grep hello, so here this is showing this. So if I do grep hello M3, then what should be the output here?
First 3 lines.
Yes. So this M stands for the lines that match and not the count of the match itself. So you can see, although we told 3, it is matching total 4 times. So it does not count how many matches there are, only the lines of matches. You can see it in the man page also. Stop reading a file after M num matching lines and not matches itself. So
it's basically counting the number of FNRs.
yeah, basically. So the lines and not the matches. So we can also print the name of the file and not the matches itself if a match is there by using the L command. So it will only simply say that the file hello has the match. So this is confusing because both of these are hello. For example, if I search for apple in the words.txt and do L, it will simply say words.txt because words.txt has a match. So it will not print the lines that are matching or the count anything. It will only print the name of the file that match. So this is useful if you are matching on multiple files. So for example, if I am matching on multiple files using star, so I'm matching on many files, then it will print all the files names that has that. So for example, fruits, patterns, and words. So fruits, obviously we created, it has apple, and patterns also we added the word pineapple in it. So if you remember, it has pineapple, which contains the word apple. So that's why it is printing all these. And here, if I obviously give, let's say W, so pineapple will no longer be matched. So then it will only say fruits and words.
Why?
Because pineapple is not apple, right? So if I give W, that means match the whole word.
Okay.
Yeah. Okay. So O we already saw. There's also Q, which does the searching, but it will not print anything to the screen. So for example, if I search for apple in the words.txt with Q, it will simply not print anything to the screen. But from the exit code, we can understand that there was a match. So exit code 0 means a match was there. Whereas if I search for something else, then the exit code will be 1. So if you do echo dollar question mark, exit code will be 1. So that means that was not there. So this is useful if you want to use grep inside a if condition or a while condition. So if or while, we'll see next, use any command for their condition. So we cannot give booleans to if or while. We can only give commands, and the exit code of those commands determine whether that will be continuing or not. So the last things we'll see is H. So H will basically print the line along with the name of the file. So here, if I do this same, not this, the same thing with H, so it will print the matches, but also with the name of the file. So this is again helpful when we are actually searching not just one file, but many files. So it's hard to see because there is a lot of output, but you can see that for fruits, we have apple, and then for patterns, we have pineapple, and then for words, we have all these apples. So if I then add, let's say W here, then we can see that only things that have apple as words are printed. So pattern is not printed, only fruits is printed. So this H is like useful when we are searching on multiple files. So let's say I'm just searching in a folder. I want to see if like a line of code is there in some file in this folder, but I don't know which file. So I can use this -H to show me the file name and also the line in which it is there. If I just want the name of the file, I can use L. But if I want to see the name and the line, then I can use H. And if I want to see the name of the file, the number of line in which it is there, and the line itself, then I can use -HL. So this will then print the line number. So you can see in the first line of fruit, we have apple. In the 21,000th, there's something line of words.txt, we have all these words. And so this becomes useful when you're searching for some code in some big code base. So this prints the line number. And instead of giving star, what we can do is we can directly use the R flag. So R means recursive. So star will only search for files in the current directory, whereas R will not only search files in current directory, but also all files in the subdirectories. So it will recurse all the files and folders in the current directory, and it will search in all those files. So you can see, 1 second. I search for with HNR. Okay. Okay, I'm not sure why this is not finding in the words.txt.
Do you want to give R as a separate minus R?
Which one?
Grep -HN, then a minus R.
No, a direct HNR should also work.
W also can be.
Okay. No. The issue is because this file is not a file here. This is a link. That's why. So this file is a link to something else. So H does not follow links if it is doing recursion. So that is the issue. So let me just copy that file here instead. That should be better. And make it words.txt, and I override this. Okay, maybe word.txt. Okay, so if I run this now, you can see all the matches in Word is also being printed.
And minus W also can be printed along with H and R, right? I mean, there's no reason why it should be separate.
Yeah, we can have that also. So any flag that we want to add, we can add it here. So if you're using R, then H and N are not required. So by default, H is not required. So by default, it will print the name of the file, because grep assumes that if you are recursively finding in files, you would also want to know which file you found it in. So the H would be automatically assumed if you're using R to find it recursively. So for example, if this word.txt is not in the current folder, so let me make a subfolder and move this word.txt in that subfolder. So now you can see if I do grep apple in the star with let's say hn, so it prints only in the words.txt and the fruits and patterns, but it is not printing from the word.txt, which is inside the folder. So if we use R here, then R will even go through that. So we don't need to give the star anymore. So it will go through things inside subfolders. So you can see subfolder / word.txt is also searched by grep.
So if we use capital R instead of small r, then we'll follow the symbol link as well.
Okay. Yeah. So you can see it's also printing for the words.txt, right? So yeah, if you use small r, it will only follow, like it will not follow symlinks. If you use capital R, it will follow symlinks also. Yeah, I was not familiar with this one. Is it in the man page, right?
Yeah, I got it from the man page. Yeah, actually, if you go a
Yeah.
little bit down, you'll see capital
Yeah,
R.
yeah. So you
Unlike
can,
minus R, yes.
yeah. So we have minus R, which is recursive, and we also have capital R, which will dereference recursive. So even if it is a link, it will dereference that. So it will follow a symbolic link, unlike minus R.
Potential quiz to question.
Yeah, anything can be asked.
Don't give ideas, yeah.
No, I am not setting the paper. So
So the questions are already set. The good thing is now it's set. So
yeah, I guess. So that is more or less all the things, and we also have a way of printing a few lines above, below, and both above and below a match. So for example, if I grep out the word pineapple, is that correct? Okay, if I match this in words.txt, so we get these three matches. But if I want to see what is present one line above this, I can do A1. So we will get one line above this pineapples, and sorry, A is after. So it is always confusing. So one line after pineapple is pines hyphen apple. One line after pineapples is directly this one. So there is nothing else printed here. And one line after this is pine bank. So we can use A to print one as many lines after as we want. So we can also give 10 to print 10 lines after it. And if there is not 10 lines after it, then it will obviously not print 10 lines. So you can see this was the second line itself. So there is nothing between this and this. It only printed what was there in between. And in the last one, it's printing all the 10 lines after it. Similarly, we can use, yeah.
So this can be used for bigram analysis then. Like if I got a bunch of text file with words,
Yeah.
and analyze the co-occurrence of word 1, word 2. So this output can be again put into WC-L to do the count.
Yeah, you can do that. So although like it would be like a roundabout way, but yes, it is possible. So similarly, B is used to print lines before a match. So if I do this way, so you can see before this is this itself, so nothing is printed. Before this is pine dash apple, and before pineapple is pine anoma. So similarly, we can also give as many number as we want, and all those lines before that will be printed. So and combining A and B directly, we have C. So this is above and below. It will print this many. Right. And here it is not much visible because it is contiguous, so it's not separating anything. So yeah.
Yeah. So this minus A and minus B, they print a line after the match and before the match. What if I want to print the word or whatever print the word that is beside the match? So if I have a line, let's say hello, my name is Yash, and if I want to match then how do I print the word that is on the
AWK.
No, by default it will print it, right? So if you are using grep will print the entire line where there is a match. What is happening? Okay, grep will print the entire line where there is a match. So here, because it is single word in a line, it might look confusing. So like here, I am doing grep hello in the hello file, right? So by default, it's printing the entire line. So we
right,
can,
right. So it yeah.
yeah, so we can get
If I
it to
want
that.
those two things, I can just have a dot star, something
Yes,
like that.
yes,
Okay,
you
and
can
then
do it there. Yeah.
got it.
Yeah. So here, let's say you just want the thing like the word after hello. So what you can do is you can do grep and then a space and then the word that you want, right? So maybe A to Z or some pattern star. So it will then match the next word. And then if you do minus O, so it will only print that matches. And then you can do cut with the space and you can take the second field to get only the word after the hello. So you can see after hello we have hello, after hello we have how, after hello we have world, and after hello we have hello.
Yeah, got it.
Yeah.
Okay, just one more question. Why did you? So if I do this A to Z star, shouldn't it match the entire line?
No, because space is not A to Z, right?
Oh, okay, right.
Yeah.
Got it.
So ideally, you should not use A to Z if you want to match a word. So ideally, you should either use A to Z 0 to 9, or you should. So the same thing is alnum. So you should use alnum. Or what you can do is you can simply say anything that is not a space. So you can say not space. So that will also do the same thing.
All right, got it. Yeah,
Yeah.
thanks.
Okay.
Shahid,
So-
sorry, I didn't get that, Shahid. I mean, his question on why should we only match? Sorry, just go back a couple of.
Okay, let me just rerun it. So we ran this, then we ran this.
So the earlier one, the one before this, where with the space, he said the whole line is not getting matched.
Yeah, so if we only do this, so if I cat the
Okay.
file, so it will not match R
Yeah,
and
yeah.
U.
Only O, right? Okay. I didn't see the O part. Okay, got it.
Yeah,
Got it.
yeah, because we have
Got
the
it.
O. Yeah. Okay, so if I do grep, let's say of two things, pineapple and mango on the words.txt. So you can see, okay, pineapple again spelling I have made mistake. Okay, so you can see that these two are there. And if I let's say do A1 or something like that, so you can see if there is something between the matches, so then it will use the dash dash to separate them. So this means that this is one of the match, and because of A1, I'm printing this next line. Then there might be some other line. So this means then this is another block. So then again we have mango, and then next line is this mango, which is printed because of A1. And then again these are all matches. And again after this last match, we have this one line which is A1. Then again this is again end of another block. So this block separators are by default this dash dash, but we can also set this using this dash dash group separator equals 7. So if I put dash dash group separator equals, let's say, star star star, I should quote it. So then you can see instead of dash dash, it's coming star star star. And if I don't want it at all, I can also use dash dash no group separator. So then it will put everything together. Right. So that is,
Actually,
yeah.
here it is printing mango and the pineapple separately, or the file is written mango and pineapple separately. Like you can see that in top everything is mango, in bottom everything is pineapple.
No,
Is
that
file
is
like that, or
yeah, that is due to the file. So it is alphabetically sorted. So M is at top,
oh,
and then
okay.
Yeah, so you can see this one also, right? See mango, it is way before mango. So that's why we were getting this star here also. So
Okay. Little confused. Yeah, got it.
yeah. Okay, so that is pretty much all the important things of grep. We can just go through some other things also, like we saw R and minus R. So most other things are based on like the binary data and null data. And you can also read how regex works. So the best place to read about regex is the info grep page and the info set page. So you can come here and you can see we have a chapter on regex. So you can press enter here. So you can read everything about regex. So these are the sub chapters. So you can just keep on going down. So you can see everything that we saw in this web page. Same thing is present here also. So everything you can learn about regex from this man page as well, or you can go through this website also, which is the GNU's official website. So let's take 2 or 3 minutes and then we'll resume with the bash scripting. So let's continue with bash now. So we'll not do everything of bash because that will take a long time. So we'll just see the like we'll revise the important parts of bash scripting. So for example, let me open a shell script here. So let me create a script using script.sh. So this creates a script, and then if we are running it directly, for the command to know which executable to use to run this script, we use a shebang on top to mark what is the script type, or which executable to use to run this script, and then we can write the script inside. So a few things that we have in script is if conditions, we have while loops and for loops.
Sir, one doubt. What if we don't write the first command exclamatory mark /bin/bash?
Yes, if you don't put the shebang, then if you run it from bash, it will try to run as bash. If you run it from ZSH, it will try to run as ZSH script. So if you're using something that is only present in bash or only present in ZSH, and if you are running from something else, it might cause an issue. If you mention this, then even if you're running it from ZSH, ZSH knows that this is a bash script. So it will run this script in a bash subshell instead of in a ZSH subshell. Similarly, if you're, let's say, running a Python script, you don't want bash to run Python script as a bash script. So in that case, you will give the path of the Python executable itself. Or you can use /ben /env, and then you can put Python or Python 3. So this helps the interpreter know which executable to use to run the script. If you don't give it, then whatever you are running it from, it will run in that itself.
Okay, sir.
So we have if conditions, we have while and for loops, we have switch case, and we also have select loop, but we will not go through that today because that is not as important. And we have functions. So let's see one by one. So let's first see the if condition. So in the if, we can use like how we use in other programming languages by giving some Boolean by using these square brackets. So for example, if I do if 5 is greater than 3, so then I put a then, and then I put something that I want to print. So 5 is greater than 3. And we end the if with a phi, which is opposite of if. So we don't have like curly brackets in bash scripting. We start with then and we end with phi. So if we don't have the then or phi, then this will not work. So if I make it executable, and if I run it now this way, so if I run it as bash script.sh, then it will always run in bash, even if I'm running this from ZSH. So then we don't need to use the shebang. So the shebang is useful when we are running it this way, using /script.sh. So here I am running it from bash itself, so it will run as bash script. But even if I'm running it from ZSH, it will run as bash script. Or if I'm running it from any other shell also, CSH, KSH, etc., it will run as a bash script only, because I have mentioned that this is a bash script. If I don't mention this, then it will run as that shell's script. So here you can see if you do if 5 is greater than 3, then print 5 is greater than 3. So here, although it looks like if is evaluating this condition, if is not evaluating this condition. If does not have any way of checking Boolean conditions. If can only see the exit code of some process or some command. So here, if I do if bracket 5 greater than 3, the reason this is working is because this itself is a command. So if you go to man page of this command, okay, so man of this is not there, but if you go to man page of test, you can see that test and this command are the same thing. So if you do which opening bracket, you can see that it is executable present in /has-been /opening bracket. So this is a command, and what this command does is whatever expression you give to it, it evaluates that expression and it returns an exit code based on the like truthiness of this expression. So if this is a true expression, then it returns 0, and if it's a false expression, then it returns non-zero. So it will usually return 1. So then the return exit code of this command is then used by if to see whether it should go inside the if or not. So then, because we are combining it this way, we can directly check for some condition in if, and then we can do it. But if can also work without like the square bracket by using any other command. So for example, if I do if ls abc, then echo abc exists. So what this will do is, let me comment this earlier one out. So what this will do is it will first run the command ls with the argument abc. And then if the ls command returned a successful exit code of 0, then it will go inside and do this. So if I run this, you can see that ls, obviously there is no abc file here. So ls gives out this error, cannot access abc, no such file or directory. And because the exit, so if I do ls abc, the exit code is not 0, it is 2. So because it is non-zero exit code, that's why if then does not go inside here. So you can see it did not print abc exists. Only if I create this file called abc, then obviously ls abc will simply print that file's name abc. And then if I do /script.sh, so the first output is from ls itself. So ls is printing the file, and then because ls exited with an exit code 0, then if is going inside and it is printing or it is doing whatever we ask it to do. So here it is printing ABC exists. So if not only works with conditions, it works with any command we run, and according to its exit status, it goes inside and prints things.
So if there is a content inside ABC, it will not print, only just say ABC.
Yeah, so because ls will only print the name of the file, right? So even if I give something inside ABC, that doesn't matter.
Still same, yeah.
Yeah. So here, as you can see, if ABC is not there, it is giving an error. And if ABC is there, it is printing ABC before doing this. So if I don't want that, I can obviously redirect everything ls gives to the dev null. So we are only interested in its exit code. So we only run the command, but I don't want any output. I don't want normal output. I don't want error output. I want all of them to go to dev null. And only exit code I'm interested, because if is using the exit code. So then you can see if I run this, it does not say anything. I can also add a else part here. So I can do else echo ABC does not exist. And then it will say ABC does not exist. And if I now make ABC, then it will say ABC exists. So in either case, the error or the normal output of ls is not printed, it is suppressed. So we can use if, we can use else, and the fee always has to be after everything. So we should not put else after the fee. The else also should be inside this way. And we can also have a else if ladder. So we can keep on testing multiple things. So else if in bash is called elif. So I can do if elif def exists, then I can say def exists. I can do another elif. So I can do elif something else. Ghi exists. So I can check multiple things this way. And in the end, if all of these are false, then the else will be executed. So you can see if I rm ABC, and if I run this, so it will say ABC. So we can also change what it is printing. ABC or def or ghi does not exist. So now if I create ghi, then you can see this will say ghi exists, because this is false, then it goes here, then this is false, it goes here, and then this is true, so it prints this. But now if ghi exists and also def exists, so then it will not test this third condition anymore, because as soon as this is true, it will execute, and then it will like exit the if condition. So then you can see it only says def exists, it does not say ghi exists, even though both of them exist here. Similarly, if I now touch ABC also, it will only say ABC exists, because as soon as the if is true, the other elifs are not checked. So this is same as any other programming language. So as soon as some condition is true, the rest of the elif else ladder is not checked. So this is how if, else if, and else works in bash. So whatever we give here is a command that is executed. So the square bracket is also a command. So here if I do 5 greater than 3, this is a command. So this will not print anything to the screen, but we can see the exit code is 0. And if I do, let's say, 5 greater than 30, then you can see the exit code is 1. So this is a command that silently evaluates what I ask it, and it lets me know whether it's true or false using the exit code. So that's why we can use that in if, and we can create if conditions like this. And the difference between the single square bracket and the double square bracket is that the double square bracket is a part of the bash. So if you run it on, let's say, the POSIX sh shell, so there it won't be there. But if you run it in bash, then it will be there. So here, if I do this double square bracket, so this is created because the single square bracket had some issues like word splitting, etc. So this tackles that. So you can also search online the difference between double square bracket and single square bracket. So the biggest difference is the type of the single square bracket is, so it is both a shell built-in, and it is also present as executable in your file system. Same for the test command. So it is a shell built-in and present as executable. But the double square bracket is a shell keyword. So it's directly part of the bash syntax. Just like the if, elif, else, for, all these are directly part of the bash syntax itself and not some command. Similarly, the double square bracket is also a part of bash syntax. So this also we can use to do the same checking. So this also works the exact same way. and it lets you know the exit status by the exit code. And here also, if I give some false, then the exit code is non-zero. And here, one advantage is we can also compare regex with double square bracket, which is not possible in single square bracket. So, for example, if I do Apple matches the regex, that there is some like there is p 2 times, for example. So I can do this, and this will be true for Apple. But if I do it for banana, then you can see that it is not true. So we can use equal to tilde to match regex, and this will only work in double square bracket. So if I do this with single square bracket, it will not work because that is not defined. So you can see this is not giving you an error. So for all the things that single square bracket can do, double square bracket can also do. But this thing like matching regex, which only double square bracket can do, single square bracket cannot do.
So instead of PP, can I do P curly bracket too, like a regular expression?
Let's see. Yeah, so that works. You can do P curly bracket too. So here we can, I think, also use group. So I can say like any letter, and then that same letter present again. Okay, so it might. So there we have to see if we have to maybe escape the groups or if groups is possible or not. Okay, so I think the groups is not there. Or maybe there is a different way of doing the groups. But yeah, so the curly brackets and all is possible. So if I do this, then the exit code is 0. If I, let's say, do 3, then the exit code is 1 because there is no 3 peaks.
Sir, can you please explain this this back reference, this one, the one which is...
Yeah.
Just to add to that, Shan, just the last part that TP from there I've like lost track and I couldn't get it. Like before that is clear, but just very quickly.
Yeah. So if we are using the double square brackets, we can also match regular expression. So here I'm matching if this string matches this regex. So the string is Apple, the regex is PP. So obviously in this string we have PP, so this regex matches. So here the exit code is 0. But if I match that same thing in banana where we don't have PP, then the exit code is 1. So we can match regex this way directly in bash without using grep, sed or awk, using the equal to tilde operator.
Sir, which one is treated as true? 0 or 1, sir?
0 is true. So 0 means successful exit code. So there is nothing called true or false in bash. So 0 means successful exit code, and false means non-zero means unsuccessful exit code. So if the command was not successful, then it will give non-zero exit code. So there is also two commands called true and false. So if you run true, this is a command which always returns exit code of 0. And if there is a command called false, if you run false, it will always return an exit code of 1. So you can see the man page also. True will do nothing successfully. And if you see false will do nothing unsuccessfully. So this is useful if you quickly want to create like an infinite loop. So you can do something like while true. And here also, so while loop also never takes any conditions. So although this might look, if you're coming from C, Java, Python, etc., that this is while and then true is a Boolean. While will always, like if, execute a command and take its exit code. So here true is also a command that is executed and its exit code is taken. So here also I can actually do anything. So something like while ls abc do echo abc is not created. Right. So if I run this, so let me again comment this out. So this will keep on printing ABC is not created if ABC is not there. Else it will print ABC is created. So right now we have ABC. If I run this, it will. So yeah, if ls ABC will give success if it is there. So it will say ABC is created. So yeah. So it will keep on printing ABC is created if it is there. But if I remove that RMABC, so then ABC is not there. So it will simply like give error of the ls and it will stop. So while also always takes like command and takes its exit code. So we can use true to create an infinite loop. I don't want to put a stress on my system. So I'll also put sleep 1. So you can see if I run this, it will print ABC is created every 1 second. And this is because the true is a command that always returns a 0 exit code. Similarly, we also have false. And if I want to negate some condition, I can, so for example, here we were doing ABC is not created, right? So if I want to check not created, I can simply put a like this exclamation mark here. So what exclamation mark will do is it will invert the thing. So if this returns a zero exit code, then it will not run. And if it does not return a zero exit code, then this will run. So if I remove our ABC and then if I run this, so then you can see it is telling ABC is not created. And if I create ABC, then it will no longer go in that infinite loop. So this output is from the ls. So in if also we can use this exclamation to invert the like truthiness of something. So if instead of doing something, if something is true, we can do something if something is false using the exclamation mark. Okay, so we can also see the type of this exclamation. So this is also a shell keyword. So this is directly built into shell. So we saw this while condition. So this is useful in the multiple scenarios. So one is when taking input. So I can take like I can say while read line do, and then let's say I can simply print the line. So the read command is a command by itself, which reads one line of a standard input and stores the value that is given in the variable that we mentioned here. So instead of line, I can write anything. This is the name of a variable, and it will put it in that variable. So for example, if I do read name, and if I do like if I give any name, so then that variable name is now created, and the value given by us is stored in there. So if I do echo name, it is then stored as that. So if I put it in a while loop, what this will do is it will keep on reading one line after the other. So read line will read one line, and because we are doing it as many times as possible, so we're doing it in a loop, it will keep on reading. But when there is no more input to read, then read will return a unsuccessful exit code, obviously, because there is no standard input to read. So if it returns an unsuccessful exit code, then the while loop will stop. So this while loop will keep on running for as long as there is some line. So let me get out this, let's say the colors file. Okay, we are not there. So here we have, let me create a file. Let me just add something in this file. So here if I add, let's say a few lines. So if I cat out this ABC file and pipe it to this script, so then this read will not take input from the standard input, but it will take from whatever is the standard input coming from here. So not from the keyboard, but this standard input. So then it will print each line of the file. And it is taking each line one by one. So we can also see that if we add something here. So if I add, let's say line, so we can see the echo is running as many lines as there are. So for each line, it's printing line and then the entire line. So this is a useful way of using the while loop, and it is stopping because as soon as the file, like the cat ends, so as soon as the last line is printed, then the cat ends, and the cat basically when it ends, it sends a broken pipe signal. So then the read will also stop taking input, and that unsuccessful exit code will tell the while loop to stop. So then it will stop doing this, and the script stops. So this is a way of reading input line
And
by
so,
line.
the read name on the right pane
Yeah.
just takes the whatever we input in the command terminal.
Yeah. So read always takes from standard input. If I redirect standard input to by some other file or something, then it will read from there. So if I do, let's say, read ABC, so here it is now waiting for my input from standard input. So here, whatever I type, that will be stored in that variable ABC. But if I, let's say, cat the file ABC into read, let's say, XYZ. So this is name of the variable. So if I do this, then the first line of ABC will be stored in XYZ. So if I now do cat XYZ, sorry, not cat, echo XYZ, and you can see that XYZ does not contain anything. Okay, because we have piped it this way. So if you pipe something to read, then it is stored in that subshell, but it is not present in the current subshell. So we cannot show it directly, but this is what is happening. So if I cat a file, then instead of reading from the standard input, it takes the first line given to it by cat, and that is stored in the XYZ. But that XYZ is then lost because this is not run in my current shell. This is run in a child shell because we are running it as a pipe. So instead of doing it that way, we can do read XYZ and take the standard input from a file this way. So if I use a left angle bracket, then instead of taking the standard input from the terminal, it will take from this file. So it is same as doing cat abc pipe read XYZ, but now this is still stored in my this current shell. So here if I do XYZ, you can see that the first line of the file abc is printed. So if you see here, if I do head and one ABC, the first line is hello. So that is stored here.
So piping creates a different cell.
Yes. Yes.
About these subshells, if we just put parenthesis and some command in between, does that command get executed in a subshell?
Yes. So if you, let's say, if I run this ps dash dash forest to see my like ps output, right? So if I run it inside subshell this way, so this will ideally run it inside the subshell, but the problem with ps is that it will not show it because the subshell ends before the ps output is shown. So let me just add something else also. So for example, if I do clear and then this, actually, if I just do something else afterwards, so then you can see that the PS correctly shows you the output that this is the parent bash that I'm running it from, and this brackets cause this subshell, and inside that subshell the PS is running. Whereas if I just run it from here, it will just say bash and PS. So if I put something inside the round brackets, it is created in a subshell. So for example, if I do something like a equals 5, and if I do echo A, so here it is in my shell, so that's why I can read the variable. But if I do it inside the subshell, so if I do something like B equals 10, so then if I do echo B, so you can see B is not there because it was done inside a subshell. So that variable is not there in my current shell.
And if we precede, suppose the B with a shell, something shell, because in one of the last lecture, week 6, sir, in the set command, sir used some parenthesis shell and a command date, the date command. So does that make a difference?
I think the parenthesis shell, so if you do the dollar shell, this one, right?
No,
So if
I mean, sir use
okay,
something like
this
a
one.
parenthesis. Yeah, shell,
Yeah.
inside that shell, and then we go to command.
Yeah, so what this does is it will execute something in a subshell and its output will also be given back. So for example, if I do date here, so the date is run and the output is printed to the screen. But if I do $date, then the date command is run, but its output is not printed to the screen. Its output is given back to the parent shell. So now I can use equal to and store it in some variable. So for example, date string or something. So it's not printed to the screen, but now I can print it using date string. So if you use pen like this dollar, then instead of printing its output to the screen, it has the value is given back to the parent shell. Yeah. So this is very useful, like for command substitution. So if I want to create a variable with some value from taken from the output of a command, we can simply use this dollar brackets. So this is same as using backticks. So although like the backticks is discouraged because there is no way of understanding which is the opening and which is the closing. So you cannot nest backticks, right? So for example, if I want to do, let's say, variable equals, I am doing the base name command, and then inside the base name, I want to run pwd. So this is possible if I am using the round brackets. So you can see the where contains 77, which is the where I am. So pwd gives you this whole path and base name gives you just the name of the folder. So it is working correctly. But if I use it with backticks, then it becomes confusing. So if I do backticks base name, backticks pwd, backticks. So because the same symbol is used for opening and closing, this means this is the opening and this is the closing. And then again, we have some random letters and then again opening and closing. So this will give you an error, right? So it is always encouraged to use the dollar bracket instead of backticks. because here you can nest things inside each other. Okay, so let's also see the for loop. So if I comment this out, so there are two ways of using for loops in Bash. So one is the C style for loop. So this is how C, Java, etc. has the basic for loop. So here I can use something like for I equals some value, then a condition till which the for loop should run, like I less than 10, and then an increment that should be done after each iteration, like I plus plus. So this is there in C, C++, Java, all the languages. So same thing we can do, but here we have to use this double round bracket to put it inside. And this runs exactly same as how it runs in other languages. So if I run this script, you can see it will print from 0 to 9, all the 9. But in Bash, we can also do a Python-like for loop, which uses a iterator and a iterable. So for example, if I do something like for number in 1, 2, 3, 5, so then I can do echo number. And what this will do is it will iterate over this list of numbers, and each iteration, the value will be stored in the variable number. So if I run this now, you can see it is number 1, number 2, number 3, number 5. So this is how Python for loops works, and you can also do it in Bash this way. So,
So within two open brackets, we do number plus plus.
Yes, so if you do that, then it will increment the value of number by 1.
Yeah, if you have like
yeah, so if you do this number plus plus, then if you print it, then it will be 2, 3, 4, and 6, right? Because the value of number gets increased. So you can like do variable manipulation this way inside double round brackets. So double round brackets, yeah.
So plus number also pre-increment will also work.
Yeah, that will also work. So if you do plus number also, so this will also work. So this will also give you the same answer. So anything you put inside double round brackets, that is a mathematical evaluation. So this will be treated as a number, and then it will be mathematically evaluated. So you can also do things like number equals number times 10, something like that. So then you can see you're getting 10, 20, 30, 50. And if we just want to perform a mathematical evaluation without seeing the the value itself, or what is the value, then we do this. But if I want to get back the value, so same as the single brackets, then we use a dollar here. So if I then want this value, so then I have to store it in some variable. So now I can, like, if I remove this also, so if I do number times 10 inside a mathematical context, and I return that value and store it in a variable called val, so then I can print that also. So now you can see the number is 1 and val is 10.
In this case, we can use a single bracket as well, right? Square bracket.
Yeah, so like this, number times 10.
And dollar sign behind beside it.
Sorry. Yeah, so if we do this, yeah, this also works. But this is deprecated. So it is encouraged to use the dollar round brackets instead of dollar square bracket.
So I'm a bit confused about since there are quite 3 or 4 ways of enclosing these mathematical expressions, like we can use a single bracket or double round brackets or double square brackets. Is there a significant difference between each?
So this square bracket is like it was present earlier. So now it is no longer encouraged to be used. So I'm not sure if there is a difference between this and this, but ideally you should always use this double round brackets. So a single round bracket for command evaluation and double round brackets for mathematical evaluation. So the square brackets, we because it is a like command by itself, right, which does variable evaluation expression, expression evaluation. So that's why we reserve that for that use case, and we don't use it for anything else. Although that is still present here. So if we run it this way, it will still give us the output, but it is encouraged to use this syntax.
And what about the EXPR command?
Yeah, those are also commands that can do mathematical expression. So for example, if I do expr 5 plus 6, so this will give me 11. So expr ideally I don't recommend using, because because it's a command which takes arguments, so there might be multiple ways of getting it wrong. So for example, let me go inside a folder, and here let me do expr 4 times 5. So what is the output expected here?
20.
20, right? So we get 20. Now if I create a file which is named plus, so now if I run this, what is the output we expect?
I expect the same.
We expect 20, but we get 9. So this is because star in bash itself is a wildcard operator, glob, right? So if we do star, what star does is it will give you all the present files in the current directory. So in current directory, I have this file called plus. So it evaluates to plus here. So when I'm doing expr 4 star 5, you can see that you might think this will give you 4 times 5, but because star is interpreted by bash itself, this becomes 4 plus 5, and we are getting 9. So this becomes very confusing if you're using expr. So ideally, you should then either escape it or you can quote it in single quotes or double quotes to prevent that to happen. But ideally, you should always just use the dollar bracket to do mathematical evaluation. Or if it's something that is more advanced that cannot be done in this, like some functions or float division, like the, what is it called, the fractional division, then you should use BC. So which is a command that can handle everything. So things like if you do 5 by 2, it will give you 2. But if you set scale to be, let's say, 2, then if you do 5 by 2, it will give you 2.5. So it can also run a mathematical function like sine, cos, etc. So if I run BC with the L, then you can see I can do things like square root also. So if I do square root of 9, we get 3. So better to do complex mathematics in BC itself. So we can also do it without entering the interactive mode. So I can simply write whatever I want the answer to, and I can pipe it into BC. So that will give you the answer directly without entering the interactive mode. So use BC when you want to do something complex, or if you want to do something very simple, you can simply use the bracket. So the EXPR, it is possible to do some things with EXPR, but it gets confusing because it directly takes it in the argument itself. So symbols which has special meaning like star must be escaped for it to work properly.
Got it.
So this is how the for each works. So here I have just given 4 numbers and it is treating them like an array, but we can also explicitly create an array. So if I do an array and I put it in a single round bracket, so this is an array which has 5 numbers in here. So I can also do for number in dollar bracket array dollar curly bracket ARR square bracket at square bracket close. So this is how we get all the values of an array. And if I run the script, this will, so let me go back to that folder. So if I run this script, then, oh, sorry, let me, yeah, if I run this script, then I will get the numbers 1, 2, 3, 4, 5. So you can see all the values in the array that are separated by a space, they are considered separate elements. So we don't use commas in array, we use spaces. And one issue with arrays is that if you have, let's say, a multi-worded element, so for example, if you have something like ABC space DEF, that is the element itself. So here you can have elements with space by putting them in quotes. So you can see this also works if you print the number of elements of that array. And if I don't do this, so you can see that there are 3 elements in this array. But if I try to iterate over them, what will happen is, because we are simply doing this, it will split the words. So let me remove the val and all. Okay, so what will happen is, if I run this, you can see that it has splitted them into different iterations. So ABC is first iteration, DEF is second iteration, etc. So to prevent that, we should always quote this thing. So if I quote this, then it will preserve the multi-orderedness of each element. So then you can see, even though like this element has a space, the entire thing is present as one iteration. So whenever you're using the for loop and iterating over some array, so this might not be the like a named array. It can also be the like array of all the arguments. So even if you're doing this, then also make sure you're quoting it. So if there are some argument which has spaces in it, it will not split that into multiple iterations. It will have it correctly in one iteration. Right, so that is how for loops. So both styles of for loops in Bash works. And let us also see quickly how switch cases work. So for example, if I have, so if I read a variable from the user, so let's say number, and I can also ask, like give a prompt in read by using the -p. So this will simply print that to the screen while taking the input. And if I, let's say, take a number from the user, I can then create a switch statement by using the case keyword. So it has to be case and then the name of the variable. So it is stored in the number variable. So we put case $number, and then we use the in keyword to start the switch case, and we end the switch case using the ESAC. So ESAC is nothing but case in the reverse order. So if also ends with phi, which is if in reverse order. Case also ends with ESAC, which is case in reverse order. And here we can give all the cases by giving the value and then opening round bracket, and then we give the command that should be run. And after the command, we should give double semicolon. So what this is this is the break command. So if you have seen switch case in any other language, if we don't put a break after the case, it will simply execute the next cases also. So for example, if I don't give this, and sorry, if I, so for in Bash, just omitting that double semicolon doesn't work. We have to explicitly mention that we want to fall through by using semicolon ampersand. So if I do this, then if I run this script, then you can see it is asking a number. If I, let's say, enter something else, it will say number is not 1 or 2 or 3. But if I enter, let's say, 3, it is printing number is 3, and then it is printing number is not 1 or 2 or 3. And if I enter 1, it is printing number is 1, number is 2, number is 3, number is not 1, 2, 3. So this is because we are falling through all the cases. So as soon as we enter this case, after printing this, because we have semicolon ampersand, we are also executing the next cases. So to prevent that, we use the semicolon instead. So this means that the condition stops there as soon as we reach this part. So now if I run this, then if I enter 1, we will just get number is 1. If I enter 2, we will get number is 2. If I enter 3, we will get number is 3. And if I enter something else, then we will get number is not 1, 2, 3. So if you want to do fall through, you have to explicitly use semicolon ampersand. And if you don't want to use fall through, if you want to stop here, so equivalent of break in other languages, then you use semicolon to stop. So it will not match the next cases also. So for example, if I give another one here, then you can see that it will not print it 2 times. So even if I give 1, it will only print it once. So this is because as soon as we encounter semicolon, this entire case then stops. So you can also see that we're getting this warning that this pattern will never match, because in the previous pattern we had this semicolon. So if you have some overarching pattern, so that is possible because in switch case in Bash, we don't have to give exact values. We can also give some regex. So not regex, but regex like globbing. So for example, here if I give a number that ends with 5, I can do that by giving *5. So this means star means anything. So this is not regex, so we don't need dot star. This is kind of similar to how the shell expansion works. So *5 means any number that ends with 5. So then I can say number is a multiple of 5. And similarly, if I do anything that ends with a 0, so I can do *0, then I can say number is a multiple of 10. And similarly, if I, let's say, check for some number that ends with, okay, so there is no other multiplicity check, we can do this way. So yeah, so let's just check for these two. And okay, so we can also check if a number is even if the number ends with any of the even digits. So I can see if the number ends with 2 or 4 or 6 or 8. So here, because OR will take up the entire thing, we have to put the asterisk in all the cases. So 2, 4, 6, 8. So these are the 4 even numbers. So if the number ends with any of these digits, then number is an even number. So we can check all these. And if I run this now, if I, let's say, give 6, you can see number is an even number. And if I give 8, then we get number is an even number. And if I give, let's say, 10, then we get number is a multiple of 10. And if I give 5, then we get number is a multiple of 5. So one issue you can see that even though I'm giving 10, so here what we can do is we can check if it starts with 5 or it ends with 5 or it ends with 0, because both of them will be multiples of 5. But then the issue will be, because we are checking it here, then this will never be true. So here, if I run this, if I give 10, it will say number is a multiple of 5, but it will not say number is a multiple of 10. So then what we can do is we can move this above this. So I can say check for ends with 0 and then print number is a multiple of 10. But not just that, go to the next one. So here I can use a fall through. I can say go to the next case as well. So for any number that is a multiple of 10, that is obviously a multiple of 5 also. So it will again come here. So now if I do 5, it will only say 5, but if I do 10, it will say multiple of 10 and multiple of 5. And when we have a fall through, it actually does not even check the condition. So here actually we don't even need that separate check. We can only check for 5, because anyway it will come here because of the previous fall through. So 5 will match 5 and 10 will match both 10 and 5. And any even number will match even. And here for the default one, we can use the star. So here I can say number is an odd number or something like that. Right. So just let me know if this was clear, how switch case works.
Shan, just the and one is to the colon and semicolon and does what specifically?
So it is a fall through. So basically, once this is evaluated to be true, this condition is executed. Then this means that execute the next case condition also. So it executes this as well. So semicolon
Okay.
means stop. So it will come out of the switch case, and semicolon ampersand means go into the next case. So it does not even check it. It directly goes into the next case.
And one last one, that minus R minus P is
So minus P is to show this prompt. So enter a number. That string is shown to the screen by read itself by using minus P. So P is for prompt, and I'm mentioning the prompt. And minus R is like a flag in read, which will basically preserve backslashes. So let me quickly demonstrate that. So if I do read, let's say line, and here if I do hello and then hello like this. So if I echo line, so it contains hello, hello. So the slash is removed from it. But if I do read minus R line, and again I do hello backslash hello, so now the backslash is preserved. So ideally, if you don't want read to randomly drop backslash characters, then you should always use minus R. So if you, let's say, if I remove this, my editor will complain that you should use read with minus R. So read without minus R will mangle backslashes. So that's why by default, we should always use this. So even if your input never contains any backslash, then using and not using will be the exact same. But if it does contain, then this is the difference in the output.
okay. Okay.
Yeah. Okay, so that is the scripts, and the last thing we will see is the functions. So functions is something that we can define in a script, and it acts exactly same as how commands act. So for example, here if I define a function like let's say hello, and to define a function, we simply put the name of the function and a round bracket and then a curly bracket to give the body. So here I can simply say echo hello. So this is a function that simply prints the word hello. So if I run this script, then nothing will happen because in this script, we have simply defined a function and not called it. So to call the function, unlike other languages where we need to do say hello bracket open bracket close, here we need to only write the name. So this is exactly same as how you call a command. Same way you can call a function also. So if I run say hello now, you can see it is printing hello. So a function can also take arguments exactly same as how commands can take arguments. So for example, here I can give an argument of John and this is taken as a argument. But now inside this function, obviously we are not accessing it. So we can access arguments exactly same as how we access arguments inside scripts, that is using $1, $2, etc. So I can do $1 inside the function, and this $1 refers to not the first argument given to the script, but to the first argument given to this function. So when I'm calling this function, the first argument I give is John. So it will print hello John. And if I give, let's say, if I run the script with some other argument as the first argument, then that is not used because that is the first argument of the script and not the first argument of the function. So if I do echo $1 outside the script, then that will print James. But if I do it inside the script, then that will print John. So here I can also, instead of giving John, I can give the value of the first argument from the script. So now this means take the value of the first argument given to the script, which is James, and give it as the first argument to the function say hello. Then inside the function say hello, I am taking the first argument given to this function, which will be James. So now if we run this, we will get hello James.
Is it because of local versus global variable, right? The context, the scope of the
Yeah,
variable.
yeah,
Yeah.
kind of like that. Yes. So although any variable defined outside will also available inside. So for example, if I say my var equals 5, so if I do here echo my var, so this is present inside. So if it is defined after calling the function, then obviously it is not present. If I do it below the function call, then it will be empty. But if it is above the function call, then it is available. But the $1, $2, etc. gets overridden because the function itself also has its own $1, $2, which is the arguments given to the function. Okay, so that is basically.
And is the
yeah.
double quotes mandatory?
Double quotes is not mandatory. So what will happen is if you have, so let me
With
remove it.
someone line with a gap in between.
Yes, if you have a space there, so for example, if I give James Joyce, so if I give like this, so this is $1, $2 to the script itself. But now if I code this, so then this entire thing is $1 to the script. So here, if I remove this and remove this, here if I do, sorry, if I do echo $1 of the script, so let me temporarily remove this. And if I do this, you can see the entire James Joyce is $1. So now if I pass that same thing to this say hello without quoting it, so what happens is it gets split. So it tells only hello James. So this is because when I am doing this, this becomes say hello James Joyce. And because there's a space, the James is taken as $1 for the script, for the function, and Joyce is taken as $2. So if I don't want that to happen, I have to quote it
Double
here.
quotes, double
Yes.
quotes.
So if you use single quotes, then this will not be expanded at all. So we should always use double quotes. So now you will see hello James sir.
Actually, what will be interesting is if you put double quotes on hello $2, whether it will be blank or
Yeah,
you know,
this will be
twice, right?
no
Hello
$2 will be blank. Yeah. So if you run this will be hello and then empty.
Correct. But if you don't give double quote, it will print hello
Yes,
Joyce.
yes, yes, exactly. So if you do this, then this will print hello Joyce.
Yeah.
So that is basically all there is in like all the important parts of the shell manipulation. So let us quickly see sed and awk also. So I don't want this to extend too long. So let me open another file for sed and awk. Okay. So sed is
Can we
a
take 2 minutes break?
yeah, sure. So
Just
let's
2 minutes.
take a 2 minutes break.
Yeah.
Sleep too.
Yeah.
Sir, will us be able to complete awk and set today?
I'll try, but then because it's already 9, right? So
Yes.
I also have subjects to study. So let's see. Let's take it till 9:30 or 10.
Sir,
So
can I ask a
yeah.
PYQ question for the time being?
Yeah, go ahead. Yeah, this is 2023
May 22.
May 2023, right? We solved this already in the previous TS session. You can
I'm
just
sorry,
go
I
through.
wasn't there for that.
You can just go through that recording. So basically, here if you are substituting the entire line with the NR, so NR means the
Line number.
line number, and then you're putting a colon, and then ampersand means whatever you did the search on. So dot star means an entire line. So the ampersand will basically put the entire line there. So this will print the line number colon the entire line.
So this ampersand, which is basically substituting what we searched for,
Yeah.
this only works in awk, right?
Yes. No, it is there in sed also. So you can use ampersand in sed also.
Said also it'll
Yeah.
give me back what I've searched for. It'll work as what
Yes.
I've searched for.
Yes.
Just have one more quick question. This last question they were talking about only twice. What
Yeah.
does this mean? Only twice?
So this also we explained here that last session. So basically in this, if you see how the solution of this option is there, right? So you are running it using bash run all. So not this the correct option. So you're running it with bash run all, but then
Yeah.
inside when you are running it, it is running with bash dot slash run all. So for the first time when you are running this, the $0 will be run all and dollar name will be dot slash run all. So it will not match. So it will again go inside and it will execute the same script. So it will run itself. But then when it's running itself, it is running bash dollar name. So the value of dollar name will be dot slash run all. So in the next time it is run, it is going to have the $0 to be dot slash run all and dollar name also to be dot slash run all. So in that second time, it will not run itself again. So the first iteration runs all these scripts along with itself. Second iteration runs all these scripts except itself. So basically this runs all the scripts in the current directory twice.
I'm so sorry, my internet disconnected. Yeah.
Okay, so basically $0 contains name of the script the way you called it. So if you run it with bash runall.sh, right? So $0 will contain the string runall.sh. But if you run it as bash, are you there? Are you able to hear me?
Grep minus B.
I think it's better if you refer to that last TS session's recording or even this TS session's recording. So you can also go through that. So there I've discussed this question in detail. So the previous part also we have discussed and this part also we have discussed how like the script is running and if so how the $0 works. Okay, I think he has been disconnected again.
Yes, I'm back.
Okay, so I'm not going to repeat it a third time. So you
Okay.
can go through last TS session's recording.
Okay, thank you.
Yeah.
Sir, will we have a TA session tomorrow also, sir? Is sir?
It's an instructor session 2 to 4.
So let's continue with SED now.
Sir, there is a request. Can you just make that recording as downloadable? Like the previous one, I was able to download, but the quiz one revision session I was not able to download. The quiz one revision session. Can you please make that down?
Yeah, quiz one revision. I don't think we recorded that, right?
I think we record.
Like,
okay.
was it
No,
TA session or instructor session?
I'll message it on Discord. Discourse. I'll
Yeah,
post it
yeah,
on.
sure. Yeah, just give me the link also.
Sir.
Yeah.
So
So
last recording, where it is available, sir?
it will be there in the calendar. All the recordings are there in the calendar.
Course specific calendar.
Yes.
Okay, sir. Thank you.
Yeah. So SED basically is a stream editor. So what SED does is it will act some action that you ask it to do on each line, and it will perform that on each line, and it will print the output of that. So if you want to print, then it will be printed, and if you want to, let's say, drop that line, it will be dropped. So for example, let me let me just copy the previous few files. So let me copy the colors. I think that was in 36. Yeah, let me copy colors here, and let me copy, let's say, what did we have? Fruits. Yeah. So here we have two files, colors and fruits. So if I run SED on it, if I don't give anything to the set, so the first parameter is always the pattern. So you can see the first parameter of SED will be the pattern. And after that, we can, so we can give multiple patterns also with multiple minus e's. But if we have just one pattern, then we can omit the minus e. And then we can give multiple files to SED. So dot 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 means multiple files. So here, if I give the colors file, so you can see it will simply print out. So this is same as catting the file. So for each line, it is simply printing the line. And I can give multiple files also. So I can give colors and fruits, and it will print it one after the other. First, all the colors are printed, then all the fruits are printed. So now in this, if instead of printing all the lines, if I want to print only some lines, so we have multiple ways of doing this. So first of all, SED by default prints all lines. So if I use -n, then that default printing is suppressed. So now, as you can see, lines are not printed by default. So now I can ask SED to print some line explicitly. So here I can ask SED to print the first line. I can do 1p, it will print the first line. Or I can ask it to print the second line, and it will print the second line. I can also give a range of lines. So I can give 1,4p, and it will print all the lines matching the line numbers 1 to 4. So line 1, line 2, line 3, line 4 will be printed. And this range can also not just be given as numbers, but it can also be regex. So let us first see how we can use regex to search. So if I do 2 forward slashes, that means it is a regex. So in between the 2 forward slashes, I can put what I want to search. So for example, if I use the letter E, then I'm searching for all those lines that has E in it. So like green, red, blue, yellow, orange. Okay, all of them have E. So this won't be useful. Maybe EE. So only lines that has double E's. So now you can see only green has been printed. Or let's say if I search for the letter O, then only yellow, orange, and violet are printed. So I can also perform regex searching this way. So by default, this is BRE. So if I, let's say, want to do L plus, so this will not work. So I have to escape the plus because this is BRE. Or we can use ERE the same way as we do in grep by using a capital E flag. So then I don't have to escape it anymore. Right, so this is how we match regex. So this is simply telling to match all the lines that match this regex. So for example, if I do O, then it is matching all the lines that have O, and it is printing only those lines because we are given the action P. But here I can also match all the lines. So if I do dot, it will match all the lines. And I can also match a range of lines with regex. So for example, if I want to start with blue and go till orange, I can do blue, comma, orange. What this will do is this will find that line which matches the regex blue and the line that matches the regex orange. And for all the lines from that line till that line, including those, it will do the action which is P. So it will print those lines. So blue, yellow, and orange are printed. And instead, if I want to not print but drop those lines, so what I can do is I can first not have the dash n, so not suppress default printing. And then instead of P, I can have D. So drop those lines. So now you can see only red, green, and violet are printed, and everything from blue till orange is skipped.
Can you explain what does the hyphen small e does?
Hyphen small e simply is same as how grep works, right? So this is mentioning that this is a pattern. So if we have one pattern, we can not use that. But if we have multiple patterns, then we can we have to use the hyphen e. So here, let's say I want to print, I want to not print anything that is between blue and orange, but I also don't want to print red. So I can do multiple patterns this way. So you can see even red is dropped. If I want to give multiple patterns, I have to use minus small e. We can also
And
put
if we use an extended grep with multiple patterns,
Yeah.
do we have to use the big E only once or every time?
We have to use it only once, because if I use it here, then if I, let's say, put plus here, then you can see it is still matching the red and dropping that. So the E is applicable for all the patterns we give.
Shine, in the initial pattern, we've taken blue, comma, orange, right? So
Yes.
that is this or that is. Does that
No. So this is same as how the numbers work, right? So if I give 1, comma,
from
4,
blue to orange? Yeah. I
yes.
don't know
So
why
it
I
is.
keep forgetting it. Yeah, second
Yeah.
time. Okay, thank you.
Yeah, sure. So yeah.
So can you explain the dot slash sorry, the shed hyphen n e in the pattern slash dot slash p colors? Is it basically catting the whole file or?
Yes, it is printing the whole file except the lines which are empty. So if there is an empty line, then that will not print that.
Okay, and what does the slash d do, sir?
D means drop that line. So it is dropping that line.
Okay,
You can see
any
here.
pattern that is matched that is being dropped.
Yes, so you can see I'm matching red, right? So I'm matching red and I'm dropping that. So red is not part of the output. Similarly, I'm telling all the lines from blue to orange, drop that. So all the lines from blue, yellow, orange are dropped. So only violet and green is there.
Yes.
Yeah. So P is for printing that, and then D is for dropping that. And the most important action of sed is S, which is substitute. So let me just add the colors again. So what S does is it will do a substitution. So if I am doing substitution, we have to mention search for what and then replace with what. So we need to use some letter to demarcate the ending of the search string and beginning of the replacement string. So the search string can be regex also, so it need not be a string, it can be a regex. So for example, here if I search for red and I replace it with red, then it will print red in capital. And this can be anything. So for example, if I do red dot dot, that is also valid. So it is a regex. But the replacement cannot be a regex for obvious reasons. It has to be an exact string that is used. So the only thing allowed other than an exact string are like these special things like \1, which means the first group, \2, etc., which means the second group, and ampersand, which means what was matched. So here you can see if we do ampersand, it means first the letters RED and then whatever was matched exactly, so small RED is printed. And we can also use things like \L to make everything lowercase and \U to make everything uppercase. So instead of doing this typing red manually, I can also do \U ampersand. And you can see everywhere we have REE that has become R dot dot. So anything R and then 2 letters that has become uppercase. So you can see red is capital red, green is G capital REEN, and orange is O capital RANGE. So \U means make the entire thing uppercase, and similarly \L means make the entire thing lowercase.
And the role of ampersand here is, I know yesterday or day before we discussed, but role of ampersand here is it global or is it to print the one which is matched?
The entire thing that is matched. So here we are matching only R dot dot. So only R dot dot is put here. So like in this case, the entire line is GREEN, but we are matching only REE in there. So only REE will be there in ampersand. Whatever we are matching, that will be there in ampersand.
If you remove ampersand, what happens?
Then it will simply be dropped. So \U without anything will not do anything. So red goes away, green's REE goes away, orange's RAN goes away. So this is same as dropping something. So here we don't need the \U. We can simply do this. So this is another use case of said substitution. So instead of substituting, you are simply dropping what you matched.
And if we have multiple groupings, do we if we back reference by 1, 2, and 3,
Yes, yes.
do we separate them by a hyphen?
No, you don't need to separate them by anything. So, for example, this is very hard to show multiple. Let me use some other file. So, let me just have that dictionary file.
Palindrome, sir.
Yeah. So, we have this words file. So, you can see in words, we have all these words. So, for example, just tell me something that you want to match. So, maybe A to Z, and then the multiple A to Z is there.
3-letter palindrome. You want to search for any 3-letter palindrome contained in any word. Yeah.
Okay, so 3-letter palindrome. Okay, 3-letter palindrome is simple. So A to Z, and then any A to Z, and then the same as the first group. So we have to first group this.
3 to 1 actually. \3 to 1.
No, that will be 6-letter palindrome.
Oh, sorry.
Yeah. So if it is 3-letter palindrome, then first letter, second letter, and same as the first letter again.
Yeah.
So if I do this, sorry. So if I put N to suppress normal printing, and if I do for this, then print it. So we can see, I have to give the file also. So we can see we only get files that have 3-letter palindromes in them. But if I want only 3-letter palindromes, then I have to also put start of line and end of line. So if I put start of line and end of line, then we get only 3-letter palindromes. So here we are searching for it, but if you want to do search and replace, so what you can do is, let's say in this, I am going to do search and replace also. So let me just use another set here. So here, if I want to do the same search and replace, so what I can do is I can again search for that same thing in the search and replace. If I search for A to Z, and then again A to Z, and let me just group all of these so that we can demonstrate how the back referencing works. Okay, so here this is the first group, this is the second group, and this is the third group. So now if I say substitute this with the first group, second group, third group, then everything will remain as it is, nothing will change. So everything is exactly as it is. But here, if I, let's say, do \U, then it means make everything uppercase. So all of the letters becomes uppercase. So \U does it till the end of the replacement. So everything becomes uppercase. We can also say make this uppercase, make this lowercase, and then again make this uppercase. So we can also do that. So now you can see the first letter is uppercase, second letter is lowercase, third letter is uppercase. So here the back references will refer to the single groups that we created, but ampersand will refer to the entire thing that we search for. So here you can see the entire thing is being printed. So here if I print just \1, we get only the first letters. Similarly, \2 only the second letters, but ampersand gives us the entire all the matches, the entire match.
So Shayan, if you have to just drop the middle letter, then all I do is put -3 and 1 and just don't put the back reference to.
Yes, 1 and 3 or 3 and 1. In this case, same because they're palindrome. Yeah, so if I don't do a \2, then we will get basically this way. Yeah, so that is how like regex grouping and back reference work. So this is same in all regex. So awk, so in the gsub of awk, in the normal matching of awk, in sed, in grep, everywhere back references work the same way. So this is part of regex. Okay, so let us see some other things that we can do with sed. So we were looking at the colors. So here we can also print the number of line in sed. So instead of doing substitution, what I can do is I can give equals. So equal to will print the number of line at that line. So you can see it's printing 1 for the first line, 2 for the second line, 3 for the third line, etc. And if I obviously don't want the contents of the line, I just want just the line numbers, I can use -n to suppress the normal output, and we get only the line numbers. And if I want, yeah,
there's a $n also, something like that.
not $n, dollar equals.
Dollar equals. Sorry.
Yeah. So I was coming to that only. So what dollar means is the last line. So if I do 1 equals, it will print line number for only the first line. So it's 1, obviously. If I do 2 equals, it's 2. But if I do percent equals, this means for all the lines. Okay, so it's not there in this set, I guess. Okay, so if I do dollar equals, then dollar means the last line. So just like 1 means first line, 2 means second line. So because we will not know what is the number of lines in a file beforehand, so we cannot give a numeric number. But if I give dollar, that means the last line. So it will print the line number for the last line. So this basically is same as taking a WC-L. Right? So if I do WC-L colors, we get the number of lines is 6. So if I'm printing the line number of the last line, that is same as the total number of lines. So this way also we can get the number of lines in a file.
So let's say I want to count the number of lines and store it in a variable, then I can do that.
Then you can simply like put it in this, right? So you can
backcodes.
Yeah, this way you can store it.
Right.
Sorry, I forgot I gave a long symbol here. Yeah, so here if you now do echo val, you will get 6 here.
Sir, what is the point of just displaying the number and not displaying the content?
Yeah, so it is one of the things that you can do. So it might be required in some use case that you are using. So ideally, you can simply use WC-L if you just want the number of lines. But if you are unable to have WC, if you just have sed, you can also get the number of lines this way. Or if you want the line number of all the lines, you can use just equals to get the number of lines. So that is one of the features that is available. So you can obviously use other things also. So for example, you can use cat minus n to number each line. So that will automatically number each line and print the line along with it. So there are multiple ways.
So using this loop, so we go to a directory, there are a lot of files.
Yeah.
We don't know the file containing the maximum number of lines could be somewhere in the middle. So we want to print the name of the file that has the highest number of lines, right? So basically we can loop
we can like put in a for loop and then check it. Yeah. So sed also has an ability to read from a script file instead of giving multiple minus e's. So if you remember, we were giving multiple minus e's. Okay, so it was not here. So we were giving multiple minus e's. So instead of doing this, so there are multiple ways to do this. One is we can give multiple minus e's. Another is I can simply put that in the same string and separate them by a semicolon. So then it will do the same thing. Or this entire thing I can put in a file. So if I create a file called script.sed And here, if I put this thing, so let me just copy this and paste it here. So I don't need the quotation marks. And instead of the semicolon, now because it is a file, I can put them in a separate line. So if I have a script file like this, which has all the things that I want set to do, I can simply use -f to give the script.set and then the file, and it will run for each line, it will run all of these one by one from top to bottom, and then the output will be printed to the screen. So if you have multiple commands that you want to give to sed, you can use a script file this way. Okay, so hopefully this one is clear. So we can print the lines that we want, we can drop the lines that we want. And so here, for example, I am dropping the lines, but let's say I want to instead print those lines. So if I do this, and if I run this, then you can see by default sed prints all the lines, and it is also printing the lines that I ask it to print. So those lines are being printed 2 times and other lines are being printed once. So if I want to suppress that, obviously we can use -n, but sometimes we may not be able to change the actual sed command. We can only change the script. So if I'm not able to add this -n here, how can we still do it from the script? So what we can do is we can again add a shebang here. So what I can do is I can, in the first line, I can add a shebang, and this one will be bin sed, and here I will give the -nf. So here the -n will be taken from this, and now if I run this so I have to make it executable first. So now if I run this way with the file, obviously colors file, so then you can see it is automatically running the -n because it is part of the shebang. So you can see even though we run bash scripts this way, because I have mentioned the shebang correctly, bash knows that it should use sed to run the script and not bash itself. If I don't have this, then bash will say this is not a valid bash script. What are you trying to run? So only if we have the shebang, bash knows which executable to use to run this script. Okay, so this way we can mention the arguments in the shebang itself. So that is how sed script works. And sed also has some flags just like grep. So one of the important flags is the I. So what I does is it will make the changes in the file itself. So for example, we saw that we can use the substitution. So let me get that back. If I do the substitution, you can see all the things that had r it became red. So red, and let me remove this. So red became red, green became this GREDN, and orange become OREDGE. So if I'm doing this, it is printing the changed thing to the screen, but the file itself remains unchanged. But if I add the -i flag, then it will not print anything to the screen, and the file will be changed. So this makes a permanent change on the file. So the I flag does that. So the I, if I'm using as a flag, then it is used for making changes in the file itself. Whereas if I put the I flag inside the substitution after this, so that means do a case insensitive search. So this means that whether the R is lowercase or uppercase, the match should be still there. So I inside this means case insensitive, whereas I here with a -i means change the file itself. Right? And we can also
it's in place, it will replace the file, right?
Yes. So this will replace the file. You can see the actual file has been changed. And if you want to make a change to the file, but not the same file, if you want to store it in somewhere else. So for example, now you can see the colors is this. Let me bring back the original colors. 76, I guess. Yeah, let me bring it back. So now you can see the colors is again back. So this same thing. So if I do this without I, we can see this is the output. If I do it with I, this will obviously change the file, but we can also give a suffix after I. So if here I, let's say, put the word new, okay, so I think it has to be attached to this. or let me just use the full version of it. So in place equals new. So what this will do is this will create a new file called colors new, and that will contain sorry, so this already changed because we use this I where this was not working correctly. So let me just bring that back again, and let me run this. Yeah, so you can see now we have colors and colors new. So colors will why is this being still changed? It should not be changed. 1 second. Edit files in place, make okay, yeah, sorry, my bad. So it creates the backup as the colors new, and the original file becomes changed. So colors is changed, but if I see cat colors new, then that is the original file that we have. So if you want to change the original file but still have a backup of the original file, you can use the suffix to do that. So with I, you can add a suffix and the original file will still be changed, but a copy of that original file will be kept as a backup in the with the same name with the suffix added at the end of it. And so that is how the I works. And we can also use extended regular expression in set by using capital E or lowercase r or this long flag that gets extended. Okay, so these are basically all the flags. So there is not too many flags in sed, but sed has a lot of actions that it can do in the script itself. So as we saw, we have S for doing substitution, we have D for deleting, P for printing. So let us see also how we can only substitute in lines where some pattern is matched. So for example, here I have hello and I have hello world and I have just world. So here, if I do sed substitute world with universe on the temp, so you can see it becomes hello universe and universe. But if I want to do this substitution only on the lines that have the word hello, then I can first put the search here. So I can do search for hello. And then for the lines that have hello, do the following substitution. So if you don't mention any line or regex before a command, the command runs for all lines. So here I have mentioned it to run only for lines that match the regex hello. So only with where the word hello is there, the world becomes universe. But the line where hello is not there, world still remains world.
It's almost like an awk with a filter before the curly bracket.
Yes, yes, exactly.
So if we have to just print the lines where the replacement has happened, then minus n, is it?
Yeah, so if you no, so this will anyway not print anything. So this will not print anything at all. If you want to then print those lines, then what you can do is you can put a semicolon and again put that same thing. So you can do hello P. So then it will print those lines that have hello. But if you want only lines that was replaced, then okay, I don't think that is possible. You can do universe, but then if there was universe in somewhere else before replacement also, that will be printed.
So actually my question was wrong. So after universe,
Yeah.
the first one, if you put P, then it will print everything, is it? Like
No. So if I put P here, then that will okay, yeah. Sorry. So if you put P here, then it will print only the ones that is substituted. Okay, I was not familiar with this one. Yeah, so you can put P here. So just like we put G for global substitution and I for case insensitive, we can put P here to print the lines that are substituted. So if I don't have the minus n, it will print that line 2 times. But if I have minus n, then only that line will be printed. Yeah, nice one. Yes, if you want to not just do substitution, but also print the line that was substituted, then you can use the P here. Okay, and if let's say I want to do a case insensitive search, so we already saw that. So for example, if I want to replace not just lowercase world, but also world with uppercase. So if I run this, it will not do anything because basically the world is trying to search only for lowercase world. But if I put I here, then it will do even if the case is different. So this means case insensitive. And similarly, so this replacement is only for the first occurrence in that line. But if I have, let's say, another world here, so you can see the second world remains as it is. So if we want to replace all the occurrences, then we use G. So that will then replace all the occurrences in that line. Otherwise, it replaces one occurrence each line. I can also mention to replace exactly the second occurrence. So if I do 2, then the first one will remain as it is, and the second one will be replaced. So what will happen if I remove the I from here?
Nothing. No.
Yes. Okay.
Only the small case world will be
It
replaced.
won't change anything.
It won't change anything, right? So the small case world, this one is the first occurrence, whereas I'm searching for the second occurrence, so it's not there. And here also, this second occurrence was second occurrence because the first one was also matched because it was case insensitive. But now because it is case sensitive, this is no longer the first occurrence. So this is the first occurrence. So there is no second occurrence in any of the lines. So therefore, nothing will be changed.
Just in this command, just can you put sed minus sed flag capital I? I just remember that. No, capital I.
Okay. No, capital I is not a flag. So capital I is there. So I think what you're remembering is capital I instead of I here itself. So if you put lowercase I also, it is case insensitive. If you put uppercase I also, that is also case insensitive.
Okay. I remember capital I. So
yeah. So both are there. So both mean the same thing.
Can I have one question? Because if you're looking for examples, I have one from an old question paper. Said. Can I just show very quickly?
Yeah, sure. Go ahead.
So this is a very simple question. Choose the command that will show the CSV file without the first and the last column.
Yeah.
Okay. The awk one is clear.
Yeah.
The said ones, I don't understand why this should not work. Unless a second should not work. If you can just go through the options.
So choose commands that will show the CSV file without the first and last column. Okay, so the last option is doing said E substitute starts with not comma or dot as many times as possible, comma, and it replaces it. So it replaces things that start with something and have a comma after it. So basically the first field, right?
Yeah,
so
this is clear.
Okay, yeah, and the next part is doing the same thing for the last one. So comma and then not comma dot as many times as possible and till at the end. So that is also replaced. Okay, and why is the second one not working? So in the second one, we are doing search for starts with dot star comma. So starts with dot star comma will match as much as possible, right? So it will match till the from start till the last comma. Yes.
Last comma. Okay.
Yeah. So if you want to match any character except comma, then we use that, right? So bracket caret comma. So it will match.
If there are multiple commas, it will look for the longest string possible.
Yeah.
And that, so by default, that string will also have a comma because we're going across.
Yes.
Okay.
Yes.
Actually, we print blank because even in the second command, it's replacing the last column also with nothing.
Yeah. It will print
everything.
Yeah, it will remove everything because it starts with dot star comma. So till the last comma, it will remove, and then it is searching for then it is searching for comma dot star. So then it won't match. So only the last field will be printed, I think, in the option B.
No, because it's looking up to the last comma, right? So
yeah, and then dropping
leave the comma, right? Or it will drop the comma too.
No, the comma also it will drop.
Oh, is it comma also?
Yeah, they are matching the comma also, right? So starts with dot star comma. So that entire thing is matched.
So that means option B will only print the last column.
Yes. We have to run it to be sure. So let me just run it.
No, I created a file. I think you're right. I can actually you go ahead and do it. You'll do it faster actually.
Okay.
But I was thinking of a different reason why that was happening. So my reasoning was wrong.
Okay, yeah. Let me just create a CSV file. I'll just share my screen.
Just a file with 3 or 4 columns.
Yeah.
Yeah. Let me just create a data.csv. So something hello 1 2 something like this, and let me just change some values. Okay, so yeah, we have this CSV file. So here, if I do this one, right? So sed minus e. So let me just move it there itself. Yeah, sed minus e, and then substitute starts with dot star, comma, and G. So if we just do this on the data.csv, we will get, so entire thing it will remove till the last comma. So only GSGS will be there. And on top of this, if we add the next part, so that should not match anything because it is searching for comma and then dot star. So comma is not there at all. So this will not match anything and it will not replace also anything. So this will still print that GSGS. So basically this will remove all the fields except the last field because dot star will match till the end. So what we should do is not match all characters. We should only match characters that are not comma. So characters that are not comma as much as possible, followed by a comma that I am deleting. And again, a comma followed by characters that are not comma as many times as possible. At the end, I am removing that. So this will only give me the entire file without the first and last field.
Just it may help for later if you had to just do with this with awk.
So awk would be simpler. So let me do.
Last nf minus 1 is the last one.
Yes. So for awk, first we will set the fs. So the field separator is comma. And then for each line, what I will do is I will
$2.
Yeah. So I have to basically create a for loop. So I'll do for I equals 2.
2 nf less than nf.
Yeah, I less than nf, I plus plus, and in I cannot type today for some reason. So in here we will simply print $I. So if I print $I, then it will go to the next line. I think so. I should use printf.
Printf.
Yeah. So I should use printf with a space or like the fs value of fs. I forgot to give the file itself. So file is data.csv. Okay, sorry, not $I. So this is inside awk. So we should just
one
use...
of the options is that, John. Sorry, 1 second. One of the options is that inf I plus plus print $I, comma, and printf new line after every this thing.
Yeah, this will work. So we should not quote the $I. So it will print $I if we quote the $I. So we have to keep the $I as it is. And after the for loop, we have to print a new line. So then it will work correctly. So for each line, we are printing. So this is a little bit hard to read. So I will just create a script.awk so that it's easier to understand. So begin is fs equals comma. And then we have this for each line, we will do for I equals 2 and then I less than the last field. So I less than nf, I plus plus. And for all of them, we will do printf $I followed by the the field separator. And then after the loop is over, so after we have printed all the fields and the field separator, we will print the \n. So it will print the new line. Although like this will also print a comma at the end. So ideally I should do it till nf minus 1 and then print maybe the nf minus 1 outside without a comma. But this will also do that. So if we run
remove the, I'll tell you, remove the fs and just put a comma there instead.
So that is the same thing. So fs anyway will give us the comma. So if I do, if I just run this on data.csv, you can see it's removing the first and last, but we also have a comma at the end because we are blindly printing each field followed by a comma. So correct way would be to print till
1, yeah, and then
NF
print
minus
of-
1, and then print dollar of NF minus 1 outside quotes, and then so I don't actually need printf here, so I can just do print. So this should work. Okay, there is what issue is there? So we are getting it correctly. Okay, so this is because we have one empty line in the file, so that is issue in the file itself. Let me remove that. Okay, yeah, now it should work. So yeah, this way it will work. So we basically print till the second last field with the field and the comma, and the second last field we print without a comma. So we just print it and with a new line. So print will print that and put a new line. So this should work. And the option given here is basically what we were doing earlier. So this will print everything correctly, but it will have a trailing comma at the end. So this would be a better way to do it. So we can also actually do without a for loop, I think. So what we can do is I can do G sub maybe on the $1, right? So I can search for anything and substitute it with nothing on $1. And same if I do on $NF. And then if I do print, I think this should work. Okay, so oh, okay. So then I have to print all the fields. So basically then I have to use a for loop to print 1 till n. So yeah, this, so we can basically do the G sub on the entire $0 itself. So the same thing which we were doing in the SED one, right? So that same thing we can do in the G sub for the entire $0. So that will then work. So if I do something like starts with not comma as much as possible, followed by comma. So if we drop that, and same thing if I do for comma and then not comma as much as possible at the end of the line, and we drop that also. So this should then work. Yeah. So we are basically doing the same as the SED one using G sub inside of. So we are removing all those from $0, then we are printing $0.
Sir, I have a question for the
Yeah.
G in the SED. In the square basis, you kept cap, comma, dot.
Yeah.
Why
So
again,
the
why again comma?
no, so the comma is required. So the cap comma means any character that is not a comma, right? So here we are searching for anything that that starts with any character that is not a comma. So I don't know why they've put a dot. So they're not considering dot also. So any character that is not a comma, as many times as possible, then a comma. So the first
Yeah.
field, if we see in the data, right? So let me just show the data. So in the data, we have the first field. So it's start of line and then character that is not a comma, right? So H is not a comma, E is not a comma. So as many times as possible, and then followed by a comma. So if I don't give this comma, then it will match the entire, like it will match till here, but not the comma. So if I then replace that with empty, then this part will be dropped, but we will still have the comma at the start. Right, so we don't want that comma at the start also. So we want to replace this and the comma also. So that's why we are matching the comma.
Sorry, dot instead of comma. Why? My question is not comma. Why dot?
Okay, yeah, dot. This one. Oh, sorry. So you don't need this dot. So they basically told any character that is not a comma or it is not a dot. So ideally, this should not make a difference in this data. But then, if you have a dot somewhere in the data, it will actually stop before that. So this is not the ideal thing that you should do. You should only use comma here and not dot. So let us see that also. If we have, let's say in the data, let me change the data. Let's say one of the lines is 25.52. So just a float number. So if I, let me clear this. So if I run this with the correct one, which is just not comma, then you can, here you can see that if we are only searching for anything that is not a comma as much as possible and a comma, then it is dropping correctly. But if I am searching for anything that is not a comma and not a dot also, then this one causes an issue, right? So the first field is not dropped correctly. So this one basically does not match anything because we are searching for anything that is not a comma and not a dot as many times as possible, followed by a comma. So that thing is not present in this line. So we have anything not a comma, not a dot, not a comma, not a dot. And then that match stops here. So this dot violates that match. So we only match till here. But it should also be followed by a comma as per the what we are searching for. So whereas this is not. So it does not match this at all. So this first part is then does not dropped. So that's why this will not work if we have, let's say, some floating point value or something. So if you have dot in the first field or the last field, it will not work. So ideally, you should not put this. You should only search for anything that is not a comma. So that would be the correct thing to do. Right? Hopefully, this makes sense. So here we are doing the same thing as we are doing in the set. So here we are using set to do the search and replace. Here I'm doing G sub inside awk to do the search and replace. Okay, so let's move on. Okay, yeah, so that is basically all the things in set. So you can also do some other things with set. So like using what we learned. So just go through this website for SED. So it lists out all the things that we saw, but then also how you can combine those things to do some other things also. So there are a lot of examples. So just go through this website to also see what are the other things that we can do. So for example, you can see that a few examples are there. So number line of a file. So I can print the number of a line, and then I can also print the line itself. So for example, if I do this on, let's say, the colors, if I run this not on file.php, but on colors, okay, without this starting dollar. So you can see the value of the file is printed with the line number before it. Right. So like this, so there is nothing in this we did not see, but like this, there are ways of combining them to do some special activities. So you can just go through this website. So it lists out some of these useful examples. And similarly, for this, we also, for awk also, we have this same website. So you can go through this for awk and this for sed. Let me paste this also. So for the awk one, because awk has more syntax, so the website is a bit longer. So first it lists out all the properties or all the syntaxes of awk. So awk is basically kind of like a programming language. So it is a very less syntax programming language. So you have all the basic things like if condition, for loop, while loop, etc. So all the syntax of awk is listed out here. And then also, just like the previous one, some examples of how we can combine all the things and perform some other operations. So in awk, we have all the variables like $0, NF, FS, etc. And we also have for loops and while loops in awk, just like we have it in bash. So we have the Python style for loop, and we also have the C style for loop. So we can iterate over arrays, and we can also use the semicolon version of for loop. And in awk, all the arrays are always associative arrays. So basically dictionary in Python. So that is called associative arrays. So in awk, you can create associative arrays this way by giving the name of the variable and then the key in the bracket equals the value. So then this will create the associative array with this key and this value. And we can then iterate over all the keys using this for variable in the array. And in each iteration, the variable will contain the key. So the mango and orange will be stored in fruit one by one. And the value we can get by simply using fruits of fruit. So same way how we access keys and values in Python dictionary, same way we do it in awk also. So the syntax of awk is very familiar, and most times it's either similar to Python or it's similar to C. So you can see while loop, etc. is exactly same as how we do it in C and Java. So you can run a while loop, and you can also add concatenate strings. So unlike other languages, in awk, if you want to concatenate two strings, you simply put them side by side. You don't need to use the plus symbol. So here S and then a string with space means it will concatenate S with a string with a space. So concatenation in awk is using nothing between two strings. And in awk, we basically have a begin block, which is run before any of the lines are read, and an end block, which is run after all the lines are read. And then we can have as many pattern blocks as we want. And for each line, all the patterns are checked. So if pattern 1 is true, then whatever is present inside the braces are run. If pattern 2 is true, then whatever is present inside the brace is run. And if the first one is true, does not mean that it will not check the next one. So all the patterns are checked for all the lines. So it is checked in the order of the lines which are present, and here in the order of the patterns which are present. So for example, here, if I create a file, or let me just copy that colors file. So we have this colors file here, and let me just change this. So this is the like change one. So let me just make it back again. Okay. So we have the colors file, and here if I then create a awk file. So in the begin, we can set the field separator, what we want. So as we saw earlier, so here we don't have any fields. So if we have, let's say, a CSV file, we can set the field separator to be comma. And then in the body, so we can have multiple things we match. So for example, if I match things that has the letter O, and I can simply print that, or I can then match things that have E, and I can print that also. So if we just give print, it means print the entire line, same as print $0. And if we give print and then some column, then it will print only that column. So now if I run this, so let me remove these spaces. So if I run this with this file, script.awk on the colors file, so you can see it is being run twice. So lines that have E in it is printed due to this, and lines that have O in it is also printed. But because lines that have O in it also have lines that have lines have E, so that's why it's printed 2 times. So if you have multiple like this, where there might be same lines matching both of them, so it will print for both of them. So in this case, if we change what we are printing, so if I do O and then $1, and here if I do E and then $1, you can see the order also is according to the order defined. So even though yellow has O and E both, first it prints O yellow and then E yellow. And if I put this on top, then this will be E yellow and O yellow. If I don't want a pattern to, like a line to match multiple patterns, what I can do is I can simply do next here. So what this will do is, after this is matched, it will move on to the next line. So it will not check for the next patterns in here. So what this does is only it will print E for all of these. Or what we can do is we can put this on top, and we can put the next here. And then what it will happen is, for the ones that has O, it will only print O. And for the ones that has O and E, or only E, it will print E. Right? So we can use next to skip to the next line without checking the other patterns. We can also use next file to go to the next file altogether. So if we do this, then if we are giving only one file, then it will stop as soon as this first pattern is matched. Right? So you can see red, green, and blue, there is no O. But as soon as we go to yellow, yellow is printed, and then it does not print anything in this file. So if I give multiple files, if I give colors again, so you can see it will do it again for the next one. But as soon as again the O is reached, it will stop doing. So the
So when you're
next.
using next,
Yeah.
O should be printed first, then E, right? I think it was doing the opposite.
No. So it is, if I remove this, so let me just, yeah. So it is printing E for the ones that only has E. So because if it matches O, then it will not go to E anymore. It will only print O and go to the next line. So for ones that don't have O, it is coming till E and then it is printing E. So you can see red, green, and blue, it is printing E. Whereas yellow, orange, and violet has both E and O. So first it is matching O and it is printing O. And then because of this next, it is no longer trying to match this. So if I remove this, then it will print O and E for both. So yellow will have
Got it.
OE,
Got it.
orange will have O. Yeah.
So there is a presence of O, then it prints that line and it goes to the next line. But if it doesn't have O, then it searches for E and prints that line.
Yes, exactly. So next basically just means go to the next line.
It's like a break, basically.
Yes.
Wherever next is, inside a loop or inside a loop of a loop, whatever.
Yeah.
The moment it sees next, it will basically nothing else is executed. It goes to the next record.
Next line. Yes, exactly. Same with next file. And similarly, we have something called exit. So if I do exit, so next we saw goes to the next line, next file goes to the next file, but exit will stop the awk script altogether. So even if I give multiple files also, as soon as we reach this, the entire awk script is stopped. So sorry for that. So it will not go to the next line, it will not go to the next file, and it will totally stop there. So that is what the exit does. So we can also give a exit code to this. So if I give exit code 2, then you can see it exits with the exit code 2. So by default, it exits with 0.
And what will continue do?
Continue, if I use continue here. So, sorry. Yeah, so continue is only used inside a loop. So if you have a loop, then if you use continue, it will skip that iteration and go to the next iteration. Same with break. So if you use break also, break is present only inside loops. So if you use it outside, it will say break is not allowed outside a loop or a switch. Similarly, continue is only allowed inside a loop. So if you have a loop here, then it will, like we can use continue to skip that iteration and go to the next iteration. Or we can use break to stop that for loop totally.
Okay.
Yeah, so that is basically how awk works. So this is the basic structure. And we also have some variables here. So for example, we have the NR, which prints the number of line. So you can get the number of line this way. So if you want, you can also basically preface each line with the number of lines. You can do NR and then $0, and you can do it for all the lines. So this will basically print all the lines with the line number before it. So if you want, you can also put, let's say, a separator here. So if in print we have multiple things we want to print, we can put comma between them, and it will separate them with the field separator. So the output field separator. So the OFS by default is white space, but I can also set it to be colon, and then I don't need to put this colon again. I can just do NR comma $0, and what this will do is it will separate NR and $0 with colon, because that is our output field separator. So we also have a variable called FNR, which is similar to NR, but FNR will reset to 1 every time we go into the next file. So we can do things like FNR equals NR to check if we are in the first file or not. So we were checking for the union or something. So we can do intersection, difference, union, everything using the dictionary logic in awk by checking the first file using FNR equals NR, and the second file using FNR does not equals NR. So I can do something for the first file and I can do something for the second file. So for example, let me add the fruits also. So here we have common, which is orange, and then we have differences also. So here what we can do is I can use associative arrays. I can say ARR of $0 plus plus. So for every line in the first file, I am simply So I don't need the FS and OFS anymore. So for every line in the first file, I am simply storing the count of that line in the associative array ARR. And then for the second file, we can do multiple things. So one thing I can do is if $0 in ARR. So this means if the line I'm seeing in file 2, if that is there in ARR, that means it was also present in file 1, then I can print. So this will print the intersection. So if I run this awk script on colors and fruits, then we get only the intersection. Similarly, we can also check for differences. So I can see if $0 in ARR equals 0. So this means the negation of this. So $0 not in ARR. So then it will print lines in file 2 that is not in file 1. And similarly, if I do fruits and colors, then it will print colors that are not in fruits. And if I want to print union, so what I can do is for each line I can so I can see if so I can do this basically for all lines. So what I do is 1 second. I do for all lines if the ARR $0 equals 0, then print that line. So if it is the first time it is occurring, then we print that. So actually we don't need this. So and otherwise we don't print it. And for all the cases, we simply store it in the dictionary. So this way, if I run fruits and colors, you can see it is printing in the order of the file. So we are not sorting, so the order is not lost. So first all the contents of fruits are present, then all the contents of colors are present, but the duplicates are not there. So orange is not present 2 times. So this is another way of you doing union with awk.
Shall that not equal to, how did you say? I mean,
Yeah, so if we want to check if something is not in an array, so in Python we can do not in, but here we don't have not in. So here I cannot say not in ARR. So this will cause an error. Okay, so this basically does not do what we asked it to do, right? So we are asking for things $0 not in ARR, but this is doing same as $0 in ARR. So to check for not in, we basically, so this thing will return 0 if false and 1 if true, like other programming languages. So I can simply check if that is 0. So if this is 0, then that means this thing is false. And if this is 1, that means this thing is true. So I can then do this to check if $0 not in ARR.
Okay.
Yeah. So yeah, that is how we check for multiple files and all. So this will obviously not work if we have more than 2 files, because FNR equals NR only is true for the file 1. And for all the other files, this is true. So we cannot differentiate between file 2 and file 3. But we do have a variable which stores the name of the file. So that we can access using the file name. So for example, what we can do is for each file, we can simply say that file name equals 1. And what this will do is this will create an associative array of all the file names. So then in the end, I can simply print all the file names. So if I run this with just colors, then it will print colors. If I run it with colors multiple times also, it will print colors. And if I add any other file also, then it will print all the files names, so colors and fruits. So file name is a useful variable that can be used to see what is the name of the file that is currently being iterated over. Right. So similarly, there are also other variables in awk. So you can go through the list here. So you can see file name is there. Then we have, just like we have FS and OFS for field separators, input and output, we have RS and ORS for record separator. So if instead of separating them with new line, I want to separate them with something else, we can set the ORS to be that. So if I set ORS to be colon, so then you can see that it is separating the new lines with a colon and not with a new line. So similarly, we can change the RS also, which changes the input record separator. So by default, it is new line, but we can also change this. So it will split records by that symbol and not by new line. So this is useful if your file is, let's say, saved in Windows. So instead of new line, you have to use \r/n. So CRLF instead of just LF. That is how Windows delimits lines. So just go through these examples also, how they work and what they do. So you can see this useful example of how ternary is used to concatenate 5 records one after the other. So just go through and try to understand how this works and what this means. So we are setting the value of ORS dynamically depending on the value of NR. So if it is not 0, the modulus, then we set it to comma. If it is 0, then we set it to new line. Right? So all these are also possible by using awk. So we can dynamically set the value in each line based on value of NR. Right? So you can check for regular expression as we saw in the field here before the curly braces. So if you just give a regex, this will search in the entire line. If you give not regex, this will search for lines that don't match. And you can also match a particular column instead of the entire line. So if I do $1 tilde regex, this will match if the $1 matches this regex. And similarly, we can do $1 not matches this regex. So we can do regex matching. We can do some conditions also. So if $2 is less than 4, $3 is less than 20, all this also we can check. So just go through these and the awk functions and just try out how the functions work. So just let me know if you have any particular doubts in awk so that we can take that and then we will end today's session.
So the link of this recording.
The link will be available in the calendar itself 1 or 2 hours after the recording stops. So Google needs some time to process it. After it's available, it will be there in the calendar. So I have to also change the permissions. So once I get the mail, I'll just change the permission so that it's visible to all.
Okay.
Yeah.
Shayan, I do have one question, but it's not to do with awk. If that's
yeah.
If you're okay, I'll share it.
Yeah, go ahead.
Multiple questions, but I'll just stick with one because this is the one which gave me a headache.
Yeah.
This is the question, Shayan. This is from the same paper you were referring to.
Okay, so choose the correct statement based on the below bash script is stored in a file script.sh. OPT equals caret minus files equals caret minus x, prefix equals caret minus p. Cur OPT is empty. For ARG and all the arguments do if ARG matches OPT. Okay, if the argument starts with a dash, so if it's a flag, then current option is argument. So we are storing that argument in the variable current option and continuing. So then we are checking if current option matches files. Okay, so if the current option is minus x, then ARR plus equals the argument. So then so we're checking if we have given minus x, then what is given after minus x is stored in the array ARR. And if the current option is prefix, so if it's minus p, then that current argument is stored as the prefix text. So if I give multiple, it will overwrite. Whereas if I give multiple files, it will simply store it in the array. Then I am running a for loop again on all the arguments for I in, okay, so move $I with, so the ARR is, okay, sorry, yeah, we're not running over all the arguments, we're running over all the elements of ARR. So all the files we're iterating over and we're moving all the files to prefix I. So basically we are renaming all the files given to the script with adding the prefix before the file name. So command script usage minus x1234 minus p file. So minus x1 means name of the file is 1, minus p file means the prefix is file. 234 will be ignored because it is not given after any dash x or dash p. And script minus p file and minus x1234 will give the same output. Yes, because we are not seeing the order of x and p. We're just going over all the arguments, and if we have -x, then the next one we are storing as the file in the file array, and if we have -p, then the next one we are storing as the prefix text. So the arguments after -x option are limited to 4, so there is no such hard limit, and because we're just going over all the arguments, so this is not correct. So we can give as many as we want. The value of $1 after completion of the outer while loop will be the first command line argument given while running the script. The value of $1 after running the outer while loop will be set.
That's an error because there's no while loop in this. I think that's an error.
Yeah, there is no while loop at all, right? So I think, yeah, if you change while loop to for loop, then this is true because we're not changing the values of $1, $2, $3, etc. So $1, $2, etc. remains the same. So value of $1 after running the first for loop will remain the same as it was before running the for loop. So
Shayan, what are they exactly doing? I'm still. Let me just clarify my thought. See,
yes,
if the argument is, see, the first argument is the script itself. The second argument is $1.
No, that one is not stored in $at. It starts with -x.
That's in awk, is it? Okay.
No. So it is if you do $0, then it will be there. But $at does not store $0. $at only stores from $1.
Okay. So -x is the first argument, right? -x is the first argument, or minus is the first argument? -x is the first.
-x is the first argument,
right? So if it's saying if this $arg is opt, if it matches this, then current opt, then it becomes -x, right? Because it will match.
Yes.
So it's minus, it will become, now we are here -x, it becomes -x.
Yes.
Then we are saying continue. That means it will skip the whole thing.
Yes.
Right?
So the next if is not checked. So we are just going to the next argument.
Right.
Yes.
So now 1 has come in.
Yes.
So 1, no, it's not. So it will come here.
Yes.
If current opt is files, which is true, then it will add 1, 2, 3, 4. It will add to the array.
No. So 1 second, let me see. If current ops, okay, yeah. So for 1, it is current opt is files, and then if you're not actually making it empty, so it still remains to be that files only. Yeah. So for 1, 2, 3, and 4, for all those, it will add them to the array. So ARR plus equals arg. Yes.
So if then at some point we hit -p, if it is -p, it's saying that there's no -p here, but
no. So it is matching that first one. If arg is opt.
Correct. Yes. Then the minus, then this becomes -p. Now the current opt is -p. If the current opt is -p, then prefix text is equal to $arg, right?
Yes.
So now prefix text is -p.
No. So this is again for the next iteration, right? Because we hit continue. So -p.
Yeah. Okay.
So the file is stored as prefix text.
Prefix. So now in this we have array. We have 1, 2, 3, 4.
Yes.
Right. And for 1, 2, 3, 4, $1, 2, 3. So file 1, file 2, file 3, file 4. Is that what is happening?
Yes.
That is 1, 2, 3, 4 is being renamed as file 1, file 2, file 3,
file 4. Yes, exactly.
Oh gosh. If the files are there, absolute paths are given as arg. So this also, I didn't understand what they're trying to say.
No. This is because, see, what it is telling is if the file or directory given, so after -x we give names of files or directories, right? So if we give it with absolute paths, right? So then the files or directories will be renamed, but not be moved to other directories irrespective of this. So this is not correct because let's say, yeah. So no, it will actually give you an error. So what will happen is, let's say I give just one path. So I give /script -x / let's say user/bin/name of some file. So /user/bin/grep. So I give that, and p is, let's say, file. So what it will try to do, it will try to move /user/bin/grep to
after file.
Yeah, so it will do file/user/grep. So if the file folder does not exist, so it will throw an error. If the file named folder exists inside their user does not exist, it will throw an error. If the file named folder exists inside there a user named folder exists, and inside there a bin named folder exists, only then it will move that user bin grep into the current directories folder file inside their user, inside their bin, inside their grep. So it will basically put the prefix before the path of the file itself, right?
Which basically is an error, right? I mean,
yeah.
You can rename it. You can rename it to anything. It doesn't matter, but it will not be moved to the directories. Huh?
Yes. So if the directory and every subdirectory is present, then it will be moved. So, for example, if I do this script with
within the square bracket -d $I. I mean, then I think it will be fine.
Yeah, if we check if it's a directory, then obviously it's better. But even in this case, if let's say I run the script with -x / abc, and the prefix I give xyz. So if a folder named xyz exists in my current directory, then it will move it successfully. It will move the /abc into current folder xyz/abc. But also obviously we need to have permissions for that. So if you don't have permissions, then it can't move. But yeah, if we have permissions, then it will move it that way. But if it is, let's say the file is /abc/def, then it will also need to have those subfolders present in the current directory. So I'm not sure if I'm making myself very clear. So let me just share my.
Let's leave the option D. I mean, it's okay.
Oh,
I
yeah.
mean, just too confusing. I just wanted to know if I've read the script correctly.
Yeah. So this is basically going over each argument, and if it starts with hyphen, then it is treating it as it is an option. So that will just store that as current opt and continue. Then the next argument will then be treated as if it is an option to that given flag. So if we have given X and then something, so it will treat 1, 2, 3, 4 as if we have given those for the option X. So then we are checking if it is X, then add it to the array, and if it was P, then store it as the prefix text.
Thanks, Shan. Just for everyone else, the paper after this term, right? This is March, not a Jan term. The paper after this was actually quite tough.
Which one?
The one after this.
No, which year?
2022.
2022 Jan term.
This was Jan term, 2022.
Okay, so May term.
The next term, May, whatever, right?
Yeah.
So that one was actually, I found it very tough. So if everybody's okay in tomorrow's revision session, we can take it up. I'm talking to everyone else. Just take a look at it if you guys want to discuss it tomorrow in the revision session.
Yeah. I think that tomorrow revision session is not there, if I'm not wrong.
Is it?
Yeah, okay. I think so, yeah. So May 2022, I have discussed that paper in like the mentorship. So I'm not sure if I can share that recording because it was done in the mentorship. I'll try to at least share the PDF if I have the PDF with me.
Something has gone wrong. Okay, thanks.
Yeah.
It has gone wrong.
Yeah. Any other issues? Any other doubts?
No.
Okay. Yeah.
Someone shared a link to this spreadsheet, and in that spreadsheet we have the recording for the session you're talking about, where you discuss the May term.
No. So the I think you're talking about the resources spreadsheet. Yeah. So that has all the TA recordings. So that I discussed in the mentor session. So that is not there. So in that spreadsheet, you will find the recording for 2023 Jan and 2023 May. So today I thought to do 2023 September, but then we are doing this revision session, so we could not do the 2023 September. So the previous two are there. So 2023 Jan and 2023 May, both the recording and then the annotated PDF is there. So in the PDF also you can see the details of why each option is true, etc. So let me just share my screen and show that.
Tomorrow the 2 to 4 session will not be happening.
I'm not
Something
sure.
is wrong with my mouse and laptop. I'm just going to log off. Thanks everyone.
Yeah, thank you. Okay, so yeah, you can see that the recordings are obviously there, but also in the PDF you can basically see like some annotations about like why each option is correct, etc. So you can also go through the PDF if you are interested or if you don't have time. Otherwise, you can also go through the recording. So there, a more detailed explanation is done. So that is 2023 Jan and 2023 May. 2023 Sep. If I have time tomorrow, I'll try to do and put it here. So we won't have a session, but then at least I'll try to add the PDF if it's possible. 2022 ones I have not discussed in TS sessions. So just let me know if you have any other doubts. Otherwise, let's end this session. So I guess all of you also might be hungry just like I am. So I'll just stop the recording.